Você tem pendrive?
Eu acho que eu esqueci lá em casa também. Mas aqui, Charles.
Seja bem-vindo ao Centro de Convenções da CDL-BH. Veja agora algumas informações sobre nossos espaços e conheça todo o conforto, modernidade e segurança que oferecemos. Para seu bem-estar, o ar-condicionado foi programado para deixar o clima aconchegante sempre a 22 graus. Em caso de incêndio, nada de pânico. Temos extintores estrategicamente posicionados e saídas de emergência sinalizadas. Em caso de queda de energia, luzes de emergência se acenderão automaticamente, guiando você para a saída mais próxima com total segurança. Pensando no acesso, este moderno espaço foi projetado com rampas, elevador e plataformas de acessibilidade para possibilitar a circulação de todos. E para que sua experiência seja completa e agradável, neste espaço é proibido fumar. Também estão proibidos alimentos e bebidas. Não esqueça de silenciar seu celular. A CDL-BH agradece a sua presença e espera que sua experiência seja produtiva e memorável.
Quando o futuro de uma obra depende do que está embaixo do solo, é preciso confiar em quem entende cada camada da terra. Desde 1985, a BVP transforma desafios em soluções que sustentam grandes obras. Ao longo dos anos, nos reinventamos e crescemos, gerando valor nas relações que construímos. Com inovação e rigor técnico, garantimos segurança operacional e otimização de recursos para nossos clientes. Criamos soluções integradas em geotecnia e hidrotecnia que transformam a engenharia. E assim, lançamos as bases do futuro com os pés firmes neste terreno. BVP, construindo relações de confiança.
Bom dia a todos, bom dia a todas. Depois de
Good morning, everybody. After such a enriching day yesterday, we're back. It's promoted by the Brazilian Mining Institute, IBRAM. If you're here today, it's a pleasure to see you again. And if you're new here, welcome. I am Marcilia Pereira, and it's a pleasure to be here the second day with you once again. We would like to emphasize that this exchange of knowledge is only made possible because we have amazing sponsors. That's why we want to point them out. In sponsoring the panels, we have Andritz, represented by Marcelo Matos, the sales manager and services manager for mining, and Carlos Gouveia, he's the sales manager for mining equipment. We also have sponsorship from CBMM, represented by the chairman, Ricardo Lima. In the bronze tier sponsorship, we have Alzenco, represented by Mateus Moll, the environmental and geosciences manager or director, and Gonzalo Covarrubias, he is the vice president for geosciences and environment. We have Nexa, represented by the general manager and SSMA, in Environmental Department, Adriano Soares. In the silver tier sponsorship, we have Samarco Mining, and we would like to thank the president, Rodrigo Vilela. Diamond tier sponsorship, BVP, geotechnical engineering, and hydrotechnical uh, studies, here represented by the Managing Director, Paulo Sella. Thank you very much for your support, sponsorship, and your attendance. Now I'd like to ask for a round of applause. In our schedule today, we have lectures, um, the masterclass, and 4 panels with debates and opportunities for interaction. In the same manner, if you'd like to ask questions, just use the QR code, which is on the backside of your badge. There will be international lecturers in the masterclass, and if you wish, just pick up the radio receivers for the simultaneous translation, which is available at the door. Let's begin our first panel of the day, panel number 5, about safety in tailings disposal on stacks. We'd like to invite the moderator, Paulo Franca. He is the managing director for FZ Consultancy and Projects. As a panelist, we have the general manager for Vale Geotechnical Engineering, Breno Castillo, and the professor from the UFGRS and director for analysis consultancy and geotechnical engineering, Fernando Schneid, and the managing director for WALM Engineering, Sergio Freitas. Thank you very much, and I'd like to ask Mr. Paulo Franca to conduct this panel. Good morning, everyone. I'd like to first thank you, thank Ibran for the invitation. Usually, I'm often seen in those debates, but I still would like to thank you. It's going to be a pleasure to talk with my colleagues. We have representatives from mining companies and 2 from consultancy companies. It's going to be a very interesting debate. I'm going to begin by making an introduction. Of course, I have my cheat sheet here to make it easier. And it's notorious after the last accidents, especially the last 2 most recent ones, the companies began a very intense process of reviewing the processes, beginning with tailings disposal, especially filtered tailings. There's a very important journey of knowledge, a lot of work being done, a lot of projects being well conducted, and effectively the work began like nearly 10 years ago. Some companies with more volume of production began their work, and 5 years ago we saw those larger scale projects beginning. We have been operating structures with amazing production rates of about 22, 23 tons of tailings per day, and more recently we have begun structures with over 50,000 tons a day. We have also projects in store above 100,000 tons of tailings a day being filtered and stacked. This certainly places Brazil in a very prominent position, and there's a good side and a bad side, as with everything in life. One of the first points that we must acknowledge is that filtration and stacking cannot be seen as the only possible alternative. The mining industry has been doing something since the 60s. If we look at Rubinsky's work from the 60s, it was perhaps the first alternative. We've been looking at many of them, but it doesn't make a lot of sense having just a single alternative as the most viable. If you might remember that there was a Mount Bully accident in Canada in 2014, and the work group that analyzed this accident, they stated that it would be important to remove more water from the tailings, specifically from stacks. It says in the report that the best available techniques need to think about at least three requirements. Surface water of the tailings deposits, that's one. To promote unsaturated conditions of the tailings with drainage provisions, and of course, in the deposits by using compaction. Those that were a part in 2023 of GeoMin, the seminar with the International Society for Geotech, the master class was by Andy Furry from Australia, and he said the following: we can easily reach the number one requirement, which is to eliminate surface water from the reservoir. And with a good probability, we can manage to fulfill requirement number two, to fulfill unsaturated conditions on tailings, but not necessarily we can manage to fulfill requirement number three, which is to promote non-dilating conditions in the tailings as a whole, specifically on the toe of the stacks, which have higher levels of stress. That's the issue that
Eu passo, então, agora a palavra para os membros do painel, né, para perguntar como que as empresas de mineração e as empresas de projeto e consultoria
consultancy companies, what they are doing to ensure the feasibility of those stacks and the continuation of the business. I'm going to talk with Breno Castillo here. Thank you, Paulo. Thank you. Good morning. I'd like to piggyback on that, and also, but before that, let me salute my colleagues here in the panel. Thank you to Ibran for the organization, specifically Julio and Aline. Now, piggybacking on what you said, Paulo, since the Brumadinho accident, the dam break there, we've been trending to that area. In the last 6 years, we have prioritized the disposal of filtered tailings. You've mentioned a few figures there, but in the South Corridor in Vale, we have the capacity of an average stacking of 9 million tons a year, an average of 25,000 per day. In the Southeast Corridor, we have a little bit below that, about 7.5 to 8 million ton a year, which is results in an average of 20,000 ton a day. But we have yearly or daily outputs of 60, 70,000. In June, we hit a record for stacking. In Ipoema Burachudo, one of our structures in the Southeast Corridor, a total of 1.2 million filter tailings stacked in a single month, in a single calendar month, an average of 40,000 ton a day. And that just gives you an idea of the challenge we have ahead of us. We're dealing with huge quantities. And for us to be able to dispose of those tailings, we need large areas. The logistics behind that is also very challenging. It's a very complex thing if compared to the previous solution, which are the conventional dams. And yesterday's lecture with Luis Paniago from A&M, he said that we should not demonize dams. In Brazil, we had dam breaks, which were upstream raised dams. But in Brazil, the upstream raised dams is very specific. Now they have already been outlawed, and the existing one are being decharacterized. No more upstream raised dams can be built, and it's hard to think about the future of mining when we think about those volumes. I mentioned only 2 corridors in Vale. Some companies have higher volumes than that when it comes to stacking rates. It's hard for us to think about a solution without dams in the future. In Vale, because we have dealt with stacks, with tailing stacks, we have our own tailing stacks managing system, which we apply to our filtered tailing stack. We adapted it, adapted the platform, the requirements for our management platform, which is very close to JSTM, and it complies with every requirement from JSTM, and sometimes we even exceed what is in JSTM. We apply this management system to those structures for the tailing stacks. For example, we have FRTFEs pointed there. We have the EOR for our tailing stack. We call them TOR. Instead of being the engineer of records, we call them the designer of records, the DOR. We had the privilege of having Professor Fernando Schneid, who's next to me as one of the members of our independent tailings review board. Professor Furyk is another one of those members. We are working so far with the best consultants available in Brazil and in the world in order to accelerate our learning curve in tailings disposal. We have migrated very quickly, typically from a hydraulic disposal, which was the preferred method of disposal in Brazil previously. We changed that very quickly to the dry stacking method. And that's why we've been making an effort to accelerate the learning curve. It's a completely different operation than what we're used to. And now I want to hand the floor to my colleague here, Professor Fernando Schneid. Okay, first of all, folks, thank you for the invitation. Thank you to Ibran. It's a great pleasure to be here today, to be able to discuss such a relevant topic. They told me I'm an international member of this presentation, that I'm no longer a part of the Minas Gerais Republic, even though I have a honorary title of citizen here. But to put things into perspective, after Paulo and Breno's words, I'd like to approach this topic from the design standpoint. And I'd like to say that regardless of every discussion we might have, this is the most relevant question. Underlying this concern put forth by Andy, it says, dry stacks, could they be liquefied? This is the concern today. That's the big question. And if you want to answer the question with another question, I would ask you, do you believe a stack can be liquefied? That's the big question, the million-dollar question. And the answer to that question at some level is understanding the level of liquefaction. It's unacceptable to state that a stack is going to liquefy because there's a whole set of procedures, operational ones, investments, in order to remove moisture and saturation from the tailings, to remove the undesired effect of the hydraulically disposed tailings, which is liquefaction. We cannot allow, after going through all that effort, that we face ourselves with the same challenge. I would remind you all that in order to liquefy, tailings must fulfill the 4 criteria. It needs to be plastic, saturated, contractile, and to present softening or softening. Out of these 4, I'd say that softening is a consequence of what we're going to do with the material. So let's leave that aside for a while, shall we? It being plastic is a consequence of mineralogy. A large part of our tailings are non-plastic. We have 2 aspects to control, which is the 2 aspects that Andy mentioned: to remove water, the moisture, and to make the material dilating by using compaction. And then I'd like to put forth the following question. What is the probability there is of having unsaturated, a very high stack, unsaturated one? The answer is 0 chance. That's the first condition that we need to understand. A stack that's going to be well compacted at optimal moisture content, it's going to consolidate with its own weight, and the underlying layers, the base layers, are going to eventually and unavoidably get saturated. The first condition from Andy It's not fulfilled, first thing. And the second thing, what's the probability of a stack having dilated behavior throughout all of its history? The answer is the same, zero chance. Because even though the material is dilative in compaction, with the rise of the stack, we change dimensions and the stress level, and the stress level inhibits dilatancy. This material is going to be contractile. Unavoidably, on a tailing stack, we cannot fulfill two of the four conditions that inhibit liquefaction. Does that mean that any stack is going to be subject to liquefaction? Of course not. As long as it's well compacted, there will be good structural stability conditions to avoid liquefaction. But this good compaction, that's on our radar. We need to do it and do it well, because once it's well compacted, it can inhibit the volumetric aspects which are associated to liquefaction, and with that, we reduce the potential risk of the structures. It's a very challenging project, as Breno said. It involves risk, and if well executed, we're going to eliminate most of the risks associated to the tailings disposal, to the hydraulic tailings disposal. Okay, folks, good morning. I'd like to say thanks to Ibran for the invitation. It's hard to talk after those two people, those two high-level colleagues. But to answer your question, Paulo, how are companies preparing for that? The answer is tough, but on paper, the designs are one thing, because anything can be done. We can design 400 meters high stacks, 500 meters, always worrying about maintaining tailings in the diliner center to avoid failure or to avoid problems with factor of safety. And to perform every test, there's a possibility of having tailings, from a bench. Is the tailings from the bench representing the day-to-day tailings? But as a designer, these are the tools we have to work with. Data from a lab, perhaps on a more homogeneous tailings, it's not the reality that we see. We've been talking a lot about, perhaps during this moment, stop projecting such high structures. Let's not go up that high. As Fernando said, let's try to limit the height. What would be the best height? This is a tough question to answer. But remembering the lecture from yesterday about communication, I asked myself, if during the crisis, a failure, we managed to communicate really well what happened, so that stacks don't become the miracle solution, the silver bullet, alongside the demonization of dams, as it has happened. It's kind of a unanimous agreement in the industry that we need to make more progress, and stacks have been making good progress in tailings disposal. They need to be considered, but these flip of switch from dams to stacks, all of a sudden and overnight in a single disposal system, is that a good thing? In Brazil especially, I think we have a learning curve which is steep. We need to develop over time until we reach a point where we can say that we are completely certain about this, about the properties of the tailings, about the compaction, with all of the framework that we have behind it to make sure of it. And then we can state very confidently that those four requirements are going to be there. And then we face ourselves with design problems, which are still in its licensing stage. How is this going to be put forth for licensing? Yesterday we saw a lecture with the FEAN and A&M people. How is this going to be viewed? And how can we make sure this is in the design and in the field, so that everything that's in the design is going to be brought to life. This is a great challenge. How can we prepare for that? Trying to have as much information as we can, ensuring non-liquefaction conditions, seeking compatible heights. Of course, that in the future this could be expanded as more knowledge is gathered and we have more comfort in doing so, and seeking alternatives to that. It's a new thing for Brazil, stacking, because weather here is so different. As you said, the stacks around the world, most of them have lower production rates and a negative water balance. In an area such as ours in Brazil, which from north to south have great weather variations, are we going to have the same MO in any area? In the north, for example, we have rainfall of 100 millimeters in a single day, a very positive balance. How is this going to be operated during the rainy season, for example? We have heavy rain sometime, and small uh, heat strokes, the possibilities of covering inflatable columns during operation to ensure all of these factors. These are things we're discussing, and also the financial aspect. This adds to the cost, and we need to ask the question, is this feasible over time for the mining companies? Thank you, folks. And now let me piggyback on what was said specifically by Fernando. A sentence that I like to use is that when we go into the dry stacking world, we're no longer a mining company and we become a earthworks company. Most of the practices are typically found in earthworks, earth moving, compaction, void ratio control, dedicated teams, 24/7, people working 24/7. It's a different world compared to the conventional mining setting. And then I go back to the question for my colleagues here. How are the companies preparing? For example, the design consultancy companies, now they are DORs of a work that's completely different than what they were used to. The EOR or DOR. How are the design companies how are they preparing themselves for this new concept, this different concept compared to the things that were done before? And the same question for the mining companies. How are mining companies doing that? I remember once a discussion, a project of stacking, a design where the engineer said, this is much more difficult than a dam, and it is. It's more difficult, more complex. I would like to begin with Sergio once again, since I was talking about the designers and how they're preparing to, fulfill the requirements. Well, Paulo, the DOR, the conventional DOR, they're there, sometimes evaluating if the design is being built if the structure is being built according to the design. As you said, we understand that the work of the DOR is going to be more intense, and that by that I mean more people. It's almost like an inspection by the designer to make sure that what's being executed is according to the design. Yesterday in Kaios Prisca's lecture, he showed a few structures where the design was changed. Myself particularly, I never saw a structure without 100% like the design. Of course, there's going to be some differences, as slight as they are. In my point of view, at some point in time, we're going to need almost a designer in the building work so that we can make sure that the changes, specifically or especially when we are at the base of the structure, we're talking about high structures where the compromise of the base in the future, we can't just say, oh, we made a mistake, we need to go back and correct it after the structure is ready with certain heights. It's mission impossible. So any changes in the design which have along the implementation, they need to be immediately corrected and assessed for future stages. What we understand is that the DOR, or the inspection team, need to be in the building works, in the work site, and with access to information, and a dedicated team for the lab testing in order to obtain data. This can't take too long because depending on the size of the pad for the stack, how many layers are going to be built every day. We're not going to have time to leave the material there. If the layer does not fulfill the design criteria, we're going to have to redo the assessment of the design, and then in the future is this going to be incorporated or not, or are we just going to remove that layer, which is not in 100% conformance.
There has to be a great interaction between the works and the designer for these deviations to be corrected in the shortest time possible. Yes, Fernand, to talk about training of the person, how you see this. Okay, let's go. Now let's try to contextualize. In the first place, the mining community wasn't ready to deal with tailings which were hydraulically disposed of. It's not a thing only of Brazil, but it is ready to deal with the filtered tailings stacks. Just to put it into perspective, what do I mean by that? In places of high sensitivity of seismic issues, people began to deal with cyclic liquefaction, not in the mining industry, but infrastructure. The places where this didn't happen, Brazil particularly, we didn't have any experience, either in design or academic, nor concepts of problems associated to liquefaction. There are few people in Brazil who knew what static liquefaction was, or cyclic liquefaction, to differentiate the residual strength. It was completely different, which we had to face as a result of the breaches that we faced internationally. And so there was this transition in Brazil to filtered tailings stacks. It was a transition on practice, but not of knowledge. We got into a world where we have good knowledge, accumulated knowledge. The Brazilian contractors that Paulo raised this, that we got now into a world of earthworks. The Brazilian companies have experience since the 60s and of the last millennium, and we accumulated experience in compaction, in big works, engineering, especially for dams. And a few countries, compared to very few countries in the world, we have this knowledge in our DNA, which facilitates a great deal. So is it all resolved? Unfortunately not, because tailings has certain specific characteristics, among them particularly the question of the variability of fines. The deposit material is different when it comes from a natural deposit. Here we have a variation of fines and heterogeneity of the material. A variation of affects the resistance, the rigidity, the permeability, the erodibility, the workability of the material. We are in the presence of a type of process that we know, but that needs to be well adapted. And this we are gradually doing, and the companies are clearly investing in this. All of society is investing in this. The universities are doing this in the training. The companies are doing this, technical qualification of consultancy at high level, and we're overcoming this challenge. The challenge isn't simple. Sergio highlighted that dams are high, very high stacks, very high levels of stress that we don't work with yet, and there's the break of particles, which is another effect. The variability of particles affects the quality. There are procedures that we cannot use. In general, we cannot use. And here somebody is going to contradict me, but the health material system doesn't work. The compaction level isn't the best control. We have to adapt our technologies, our knowledge for tailings, and we can do this adequately. A last statement is just that we're to do things properly and poorly in compaction have the same cost. It has the same cost. We have to learn to do it well done, and the companies are working in this direction. I don't have much to add to what my colleague said. Because of time, I'm going to be brief, Paula, I promise. I agree with what it's no longer merely disposal activity. It is one which looks more like continuous construction, earthworks, as you said. This involves a level of control which is much greater. Technological control for the operation of the stacks is much greater compared to practices in the past. So, as Sergio said, we need to be closer, a greater speed with the results from the lab for approval of results to be able to free up the workspace, the area available that you have. We have worked, we have moved forward a lot in the technological control, instrumentation, understanding of the stacks, and as Professor Schneid said, highlighted it, in Valley we have done experience with universities and all. We have many research and development initiatives to understand the behavior of the tailings, how the tailings will behave, especially when levels of stress which is higher. When we get to raise these heights and get to levels of stress that we've not yet experienced in practice, understand how the tailings will behave and try to, with this, improve our designs and our practice. I think that is the main point for the future of the facilities. Thank you. We're receiving some questions from the audience. Some are more specific. Some for Breno. I think these would be best to talk afterwards. But there's one from Terezinha Spars. She agreed with me beforehand. It looks like she agreed. I was going to, in the third round of questions, I was going to make a few other points, a few challenges that tailings disposal, filtered tailings disposals bring to us. One is the rates of construction. They're not determined by production of the company, but they're decided by what's the maximum pull pressure that the material can have and that kind of thing. This is a challenge. The other great challenge is we have seen in various projects the difficulty of drying the tailings. Sometimes the material between the difference with the moisture in from the filter until the optimally 16% to 20% difference. How do we get to this level? All this leads to the need for tailings stacking system, which is contingencies. What to do when you can't put it on the stack? The best contingency, in my humble opinion, is a dam. We can't demonize dams and be free of them, or separate the whole process. You talk about, I'll leave an area here for 20 days operation. That might not be sufficient in the rainy season. So this is the third round of questions. I would like to begin with Fernando Schneid. How do you see this further challenges linked to rates of construction, need for consistency to keep the operation of us at adequate levels? I'll be brief. In fact, my experience is infrastructure, more of infrastructure than of mining. There are some maxims in infrastructure when we work with earthworks. One of them is you do not have production in the rain. When you do planning over works of earthworks, you begin in the dry season, you go as far forward as possible during that window of opportunity, and you stop in the rainy season. And the mining industry doesn't stop. So, yes, there are difficulties. The stack isn't the only solution, and maybe it's not the best solution. And it has to live along with other kinds of facilities. I agree with that. There was positions, Paulo Breno before, in the sense that Brazil has to follow international tendency. The international tendency is to coexist different solutions, certainly between stacks and dams, especially in a climate like Brazil, where we have a high rainfall rate. We're not going to manage to have adequate production in the rain unless we have very low fines. It's not possible and not always desirable, and these difficulties are there. And so the coexistence between different types of solution, as I understand it, is the safest way to proceed with regard to tailings management. Well, picking up specifically the question about moisture and drying, I think is what was commented. In our operations, we experimented the opposite. We need to add water in. Filters deliver optimum moisture, the 12 or 13% optimum for compaction. Very often, the delay, the cycle between filtering and the compaction, we have to add water to get back to the optimum. It loses moisture until it is compacted. So sometimes for us, I'm speaking obviously with the exception of rainy days, as Fernando says, when we have a rainy season, which are long and intense. In fact, there's no way you can have production. The way you get around it, or either through facilities, a contingency, auxiliary, emergency cells, or disposal for, or dams, or you have areas that allow you to stack the tailings until it is in fact compacted. In our case, coming back to very often we need to add water. We had in cyanate, we had interesting work reducing the cycle, and we managed to reduce the need of input of water. We tried with as soon as the tailings are filtered as quickly as possible, we compact them. But again, when we're talking about these rates of production, it's difficult to reach this. There's no way we can dispose of all the tailings. These are the challenges that this new form of disposal finds in the tailings. As the Professor Schneid said, we can work with total tailings, the coarser with the material with the fines. We have to see what levels we manage to reach with the workability with the fine, with the coarse tailings. Otherwise, we need to find, given the fact that mining generates fines, we have to find a different solution specific for the fine tailings. I'll pass the floor. The provocation that Paulo brought, I think, is something we discussed a lot in the office. Will the mill be turn on, turn off, turn on, turn off, as the production rate is greater than the placement on the stack? The answer is maybe no. wouldn't be feasible. And then something that we have worked a lot on is that maybe the quantity of stacks or work areas, they will vary according to production and the rate of production that the stack accepts to avoid the poor pressure. When you get impediments with high production, with, as you commented, 100,000 TPF tons per day, there are cases that get 230,000 tons a day. Maybe they would have to have so many workplaces, and so it would have to have more places that maybe the dam, the production, it would be more feasible economically and technically. Now, that you have to go case by case. We had some similar work, not in the implementation of the stack, but in blasting of a few places where it was instrumented. Every time the works brought poor pressure, they would stop the works, wait for the dissipation to ensure the safety that was necessary. It's very similar with all the instrumentation as the works, the compaction generating vibrations. If any instrument shows poor pressures being generated, you stop it until it dissipates and get back to the activities. And as we have to have the areas planned for temporary areas, I joked in the office recently that, well, the rates are, if we take everything to the stack, but the production, the mill, maybe the enterprise will have 30-year working, it will have 60, because you need 30 years to be able to restack all the material that is being stored there. Of course, it's an exaggeration, but it's something has to be considered. In our case, we have to see this in the at the design stage, and designs which have licensing. If in the future there isn't an area for disposal, it can be a bottleneck in production. Let me get away from the script here, because there are two questions that are already given by the audience, which are important, not specifically for filtered tailings. What is the technological alternative? What happens if the characteristics of tailings change over time? How do you do this at the design level? And in an ideal world, as I see it, is try to understand the mineralogy of the deposit and be able to foresee what's the impact that this will have in the compaction if we're dealing with filtered tailings. It's not easy, but it's very important to try to understand how the deposit works. In iron ore, we have seen this very easily. The lithotype feeding the mill changes, increase the percentage of iron in the tailings, it completely changed the compaction curve. So in an ideal world, that would be the ideal world. Would somebody like to add to this? Fernando, for example, about the changes over time? Very briefly, this is in fact a problem. When we're talking about adapting the techniques of the infrastructure industry for mining, one of the problems is the variability. And this variability imposes some challenges that we are trying, and did a job for a well-known mining company, creating a quality program based on three principles: traceability, reliability, and storage. It's an invitation for you to think about the fact that we are in civil engineering and mining engineering in general 50 years behind, because the world, contemporary world, talks about artificial intelligence. Artificial intelligence is linked to data mining, and we don't yet have integrated systems. This began now very quickly, integrated or storage or data storage. We generated millions of data, and then we don't have an effective way to recover the data, to check the variability that might be there. That is the first point. We have to have a level of traceability which is really great to deal with the complexity of these facilities. And the other question is precisely because of this variability, the compaction curve changes. When the compaction curve changes, the critical stage, you can't follow with a degree of compaction. It's very difficult to follow the degree of compaction, and this doesn't work. So you have to develop strategies for control. This has been done that are not the conventional ones for natural deposits, but are adapted to engineering, mining engineering, following the void ratios, variability of moisture, establish strategies for control in the humid moisture, and then to the void index to not get in the way of production. There are a number of strategies that are necessary to deal with these materials. The question is very well and very relevant. Would you like to add there? This discussion is great because it shows the need, something that we said yesterday, which is communication. The mining planning has to be well connected with the process people, has to be well connected with the final disposal people, as it were. Geology, we know, has brusque changes. You say, till such and such a day, I'm in this kind of lithotype, and from then I change. And how to bring this together in the design and then in practice with what Fernando Schneid said. Maybe we need compaction, which is a little different, but which is not turn on one day. It was in the past. Today, it was 5 until yesterday. Today it's 6. The heterogeneity here is this. We have to be every day testing and getting the lab results back quickly. It's a wheel that doesn't stop turning, and in this case, it doesn't. Production continues, and this has to be a quick switch around. These changes over time everybody has to be ready for, and communication goes from extraction, mining. We had different material, put it in the plant. How will this come out? The filter has to behave in a good way. The filter wears with time. When's the time to change the filter? This communication has to be more intense. I would add only, Paulo, that the mining are inherently heterogeneous when compared to other materials of civil engineering. So in a way, we are used to dealing with heterogeneity. But as Sergio said, we need, from the point of view of the company, we need to integrate geology, prospection, mining plan, beneficiation to understand how changes in the process will influence the characteristic of your tailings. I will get into another subject here now, which has been common practice, the so-called joint tailings with filter tailings and waste. If we get the terms in English, there are various concepts. Co-placement, which is disposal, we call it hybrid. They're the two materials on the same area, but not necessarily mixed. The co-deposition, and there's some degree of mix, and co-mingling, that is the mix itself, widely used in rock stacks. You fill the voids of the stack with tailings, etc. My opinion, my private opinion, is that obviously one of the materials will dominate the behavior of the stack if they are mixed. The understanding of this mix for me is fundamental. I particularly think that just mixing isn't the best practice. I prefer the so-called hybrid disposal. They are placed in the same area without necessarily mixing between the materials. I'd like to ask the panelists about this. I'll begin with Breno, please. Of the examples you mentioned, the co-placement, which is displacement waste in same area but not mixed, I think it is by far At least, as far as I know, it is what is most common in Brazil. Co-deposition and co-mingling, special co-mingling, it reduces solutions rarer, because even from the point of view of be able to do the mix, there are difficulties in this as well. I believe that co-placement, as I said, that which is more our reality here, something that we can benefit from, tailings stacks and waste stacks, using the most competent materials for the areas that we need. This is a good solution for mining, because it allows us, as you said, find the behaviors of each of the materials and the behaviors desired, and use these materials for disposal and disposal, structuring, non-structuring. And I think this is of the alternatives that you mentioned, the co-placement is a solution which is good for mining. I agree with Breno. When we speak of the mix, something that we say, the rate of production of each material which will be part of the mix, fine, coarse, 70-30, 20-80, 40-30 of another material, waste, and yet with tailings that is more, which is coarser. For us in design, the great difficulty is that when will we have each type of material, each area of the stacking, so that we can do the stability analysis, get to a factor of safety according to the norm. Today we have 1329, but we don't know what is in the pipeline. When yesterday Iago was showing us the way. But this is the great difficulty. How are we going to deal with this in the future, even in software, to put so many zones, so many areas, and say, we have the certainty that this material has this characteristic, this is a bit weaker here. What would be the interaction between these materials for our analysis, future analysis, compared to the deposit? For design, it's difficult. The master plan of the companies don't have the clarity of how much material will be, how much is fines, coarse, and this throughout the construction of the stack, containing different disposal places with characteristics. Despite there's a small variation, there's the variation. So it is a great challenge in terms of design. What is the best disposal? When we talk about structured zone, let's do a structured zone here with the material that we have, better control, and a zone which is less structured. Do we have the rates of generation that enable this? And if this is possible, how far do we have a lesser flexibility of the material that will be in the non-structuring part? I think it's a challenge, a big challenge that we have. There's a lot to be discussed to be able to get to each type. As Breno said, we have tailings, we have some knowledge of, but remembering you don't have just iron ore tailings, we have other materials, various others. When we're beginning to go rare earths, lithium, etc., tailings aren't so conventional and known as iron ore, which we know. I'm focusing on iron ore, which is more our reality, but you're quite right, Sergio. I have very little to add in this discussion. I agree fully with my colleagues here. I'd like to go a bit ahead, get a bit ahead here. The fact to remember questions, particularly that we are still stuck in the legislation which requires factors of safety which are specific, which are deterministic. The problem of blending and co-disposal, etc., is that afterwards we're obliged to have characteristic values for all the materials, and we have to deliver to society or to the public prosecutor's office a factor of safety to ensure the safety of that facility. I remember this because, agreeing with Paulo, the blends are complicated because the blends are variable and we always have to study the blends. So it's better to do the co-disposal of independent materials. I would remember a fact that is recurrent in our concerns when we deal with waste. Waste comes from the term waste, but it is used internationally as rock waste. It's rocky material. It's large grains, particles. We use this in Brazil in a way which is more freely and more openly. When the quantity of fines is great, this waste can have a behavior worse than the tailings themselves. You have to characterize what we call as waste. This material have the minimum traceability so that at least afterwards we can have some way of finding characteristic properties to deal with factors of safety. That is a game that has to be very carefully dealt with.
Okay, so once again, I'm going to piggyback on a question from the audience. And this is a question that I'm sure there will be no agreement upon, and from the audience as well. So the question is, the tailings disposal, tailings out of spec in a non-structuring stack zone, the technical risk in dams. I'm going to offer my opinion first, and then I'm going to move on to the colleagues here. I don't think so. Disposal must be done mechanically. It's not a hydraulic disposal. It's one of the characteristics of the non-structuring zone. You're not in the flood routing, and there's not necessarily a water buildup. What doesn't stop you from saying that the structure could see an internal problem. Specifically, you have high moisture content and so forth. But I don't think it's similar to a dam. Any opinions here? I agree with Paulo. I think we need to divide what's out of specs material without proper controls, because they could eventually cause failure. But this is in no way similar to a dam, right? Typically, even in non-structuring zones, these materials are compacted. These are materials which are, by their own nature, they are dry. So there's no way that this material presents any similarity to a dam. We need to divide things. Divide what is a mere stacking of filtered tailings. Does this ensure the non-occurrence of failures? It doesn't. We could see failures in case those structures are not properly managed. However, we would not see similar behavior to what we've seen. In terms of consequence, even the probability is reduced. Even if we could see failures, it's not going to be similar to a dam behavior, not by all means. Who asked this question? Well, I think we need to be cautious. We reached the conclusion in Brazil, a correct one, that in general stacks are zoned because of the weather. We have a structuring zone and a non-structuring zone. Okay, that's a good decision. The second debate, which happened, was okay, then the structuring zone is responsible for the safety of the dam. It is responsible for the structural characteristics of the stack. Okay, that's true. So you don't need to worry with the non-structuring zone. Okay, but if the structuring zone becomes hydraulic disposal, that's a dam. And there are some dams and some discussions with international designers that come with the chimney drain between the structuring and non-structuring zone. That's why it's a completely inadequate concept to a stack. It's a concept that comes from dams. But the designer was bringing their baggage, their history. The fundamental concept of a stack, the way I see it, is that it cannot have liquefaction potential, which means that structuring zone needs characteristics and properties which are adequate to ensure the factors of safety and the stability of that stack, and that the non-structuring zone does not provoke high potential damage, which is also disposed with some strict controls, not connected to the aspect associated to stability, but to the potential damage. And yesterday I couldn't be here, unfortunately, but there was an extensive discussion about hypothetical dam break, and this is discussed to a dam break study. Both zones need, as a minimum procedure and control, the condition of no liquefaction potential. I like to insist on this point. It's the initial one, and it's been present in many of the discussions that we've been a part of, and that has been an object of concern in the international and national guidelines being produced in this area of knowledge. Well, Schneider, I believe you mentioned everything that I was thinking about. I also understand that the answer is no, and mostly because of the Denberg study, tailings on a stack, even if it doesn't have all of the, if it's not a strict compaction, the rheology of the tailings is not enough, or it tends to be not enough, for in a hypothetical dam break, it presents such a high fluidity and reaches large areas. This is going to be a great advantage for the definition of what is stack and what is a dam when it comes to these studies. If we're going to address this as a stack break study and only a landslide, and if there's any liquefaction potential that could provide fluid conditions or fluid characteristics, and then the dam break is going to be similar to the the one of a hydraulically disposed dam. But I understand that the answer is no, even with a out-of-date compaction. The rheology of the tailings does not allow it for such a large high fluidity, and this is what's going to set apart a dam, which is hydraulically disposed, from the dry stacks. Okay, so I'm going to ask a few more questions, and now we're going to talk about not such a very geotechnical topic. I'm going to ask Sergio to be the first one to answer that. The tailings dam, do they have a double function? One is to store tailings, and the other is to store water. When we go into the domain of filtration, even though filtration recovers a lot of water from the process, we lose the capacity of building up water during the rainy seasons to be used during the dry season. Therefore, it is highly likely that we're going to need to get water from the rivers for operation. In our area, we know how these water resources are compromised. I understand that this is a very important risk when it comes to making a decision of stacking. Are we going to have enough water for your plant? I'd like to ask for my colleagues' opinions here, and I'd like to begin with Sergio, please. Paulo, this is a topic where if you remove water, people go, well, and it goes through the filter, I can reclaim water there. But we know there's still some water loss because of the ore and so forth. You also need to replenish the water. Today, most of the dams have the double function, as you said, and catching water from the river without dams, it's almost impossible due to the sheer size of the flow rates required, and as well as the high number of users that we already have in the Iron Quadrangle and other areas. I think it is possible that we might need a water dam so that we can have this additional water supply for the mine. And additionally, the hydraulically disposed tailings dams, they don't generate a lot of sediments. When we move on to stacks, the rate of sediment generation tends to increase by a long shot. And in larger areas, this may be not be concentrated in a single thalweg. It's more diffuse if it's a plain area. Associated to that, we still need some facilities to contain sediments over time. Conventionally, mining says that these are containment dikes. We see 30, 40 meters high dikes with an amount of water to retain that sediment, especially in the rainy season. All of this needs to be considered alongside the water dam, which is meant only to supply water, as well as the sediment containment dikes. Either that or they could work as water supply dams so that we can have a joint operation, not for tailings, but for containment of the sediments from the stacks and the water. And what we said, one of the things that the amount of dust that the stacks could generate, specifically during the dry season, that could be somewhat of a concern for those dams, for the plants and mines which are close to that. And then we need, during the dry season, a lot of water to spray and reduce the dust generated. Besides the return water from the process, this water that is needed to suppress dust, depending on the size of the stack, might be a lot more than what we are using today. Actually, I agree 100%. I don't have a lot to add. It's basically about following international standards according to different structures. We are seeing some challenges in those stacks in complying to environmental legislation and specs because of the increase of water turbidity, the buildup of material in suspension. We do need structures to contain sediments and in water management. This is international standards. Nothing to add here. I had another round of questions I wanted to ask about legislation, but because we have a specific forum about legislation here, I'm going to ask a few questions from the audience. The first one is what kind of extra care you need to have with the internal under drainage in disposal of dry stacks. I'm going to offer my opinion and then move on to my colleagues here. What we've seen is that besides the spring drainage, the conventional one, you need drains to help in the dissipation of pore pressures during the construction. Those drains are highly efficient. Usually they are multi-level drains. You don't place them only on the base. You're going to apply them and implement them in different levels. And we've also learned that you apply tailings with a certain moisture content, and over time, due to the construction process, this moisture is being reduced and it's caught by the drains. In the sizing stage, you also need to establish what's the moisture that tailings are going to lose when it's applied on the tailings and it's going to feed your drains. I've seen a lot of success in the implementation of those drains. And I once again highlight the implementation in different levels, different heights of the stack, where it no longer reaches the tailings mass being disposed on top of it. I would add only the importance of instrumentation so that we can ensure that we have information that show us the dam specifically, due to the drainage system, is working properly. Not much more to add about the drainage system per se, Paulo. Just a quick reflection, a word of caution. In reality, the underdrain is a fundamental matter in stacks. The Thalweg drainage needs to be generous, but the intermediary and multi-level drainage, my first reaction was surprise when we began discussing that, because this low permeability material for infiltration, that's one thing that, in general, earth fields and infrastructure have no drains. We are introducing that in the mining industry. My only reflection here would be that I'm concerned that the drain could work not as an element to remove water, but as an element to bring water. A good part of the stack is unsaturated with low permeability, and multi-level permeable elements could bring water, catch water instead of removing it. This needs to be very well conceived so that we don't create a problem where there isn't one. We need to think about the best solution for each structure. Okay, so now we're gonna go on to the next question. In the high stress studies we have approached frequently in the design of stacks, how can we evaluate possible arching of tensions or stresses on those structures? Fernando, I think this is a great question for you. I love you all. These are really simple questions, right? We're making a mistake, and if you allow me to say so, we're talking about high stresses, and this is a problem. How do we calculate high stresses? The height of the stack multiplied by specific weight. That's wrong, because there isn't a failure surface, which is along all of the routing submitted to those very high stresses. We usually are close to the slope, and the average level of stress on those stacks is lower than the maximum stress generated by the height of the stack. We are merely creating a problem where there isn't one. There's some equipment bringing those tests to unnecessary stresses. They're being excessively conservative. That's my first point. And the second point is that we understand that we need dilating behavior, and the dilating behavior is inhibited by the addition of stresses, which make that the confined soil cannot dilate and the particles break instead of dilating. This needs to be studied and assessed. And there is another concept that we have not discussed, which is connected to the general design concept, where it's showing up in every guideline that I've been reading, and I agree completely, which is design to closure. Think about the structure not in stages, but think about it as a whole, a holistic view. Company, stakeholders, society, everything needs to be up to speed on the structure. The maximum height needs to be considered even in the first levels of design, because the properties of that compacted material, when submitted to low levels of stress, is one. And the same material with high level of stress has different properties. You need to design this stack for its final condition. That's what it means to design for closure. I have a comment to add, and this stops, how can I say, the future improvised solutions. If the mining company finds more ore, we're going to go on with the stack, and that could be a very high risk. There's a lot of knowledge there, and to make any addition in the future could be troublesome. Dams, when you talk about dams, if we're talking about raising dams, we need to be more careful. That's where it all begins. There's another question here. In the beginning of the lecture, I mentioned something about the the best available technologies, the three requirements which are important to promote the dry stacking with quality. Eliminate surface water from the reservoir, promote unsaturated conditions and dilative conditions all the time. Besides those three, with the experience we have, the question is, does the panel see any other best available technologies other than those three ones? Things that could be lessons learned. I believe one of the ones that were mentioned here today is the traceability of the understanding of the mineralogy of the materials. This is a point where we've been learning a lot from its fundamental importance on those texts. Does the panel agree? Anything to add? I'm the only one talking here. That can be true. Okay, so let's go on to another question. And since nobody wants to talk, I'm going to ask Breno. How are the companies articulating with the government and licensing bodies the importance of dams and stacks? That's a great question. Well, I think that immediately post Brumadinho dam break, society in general opted to migrate strongly and quickly to filter tailings. I believe this accelerated the learning curve in Brazil. At the same time, we virtually stopped at least building new dams. A lot of mining companies still operate dams, but the building new dams has been reduced drastically. I believe that with the Querido learning after those 6.5 years, we've noticed that now perhaps the best solution for the continuity, and that's a recent thing that we realized, the best solution would be operating both assets, operating stacks, but to also have dams, whether for fines, containment, or for whatever it might be, depending on what the project needs. And we've been articulating that with the government. We are really close with the public prosecutors, with the National Mining Institute, and once again, quoting Luis Paniagua from the National Mining Agency, it's hard to imagine a dam-free mining industry. I believe the same process for reaching that conclusion that the mining companies had, all the other entities that are part of this, all the other stakeholders need to undergo this process. We need to make these projects feasible for mining in the company. I believe that in the next years, there will be maybe a gradual return to disposal in dams or using dams for all the other situations that we have mentioned here, for water supply, for sediment containment. That's what I imagine is the future, is the next step, perhaps when it comes to adjusting our legislation and our practices. Very quickly, the last few years were very difficult in international meetings because all that was talked about was the Brazilian accidents, and we sounded like the greatest criminals. In the last mine waste seminar, there's a very interesting chart, and we talked about that a lot, which shows the structure that are highest risk in the world, the map of the high-risk structures in the world. And Brazil is in a very privileged condition, 6th or 7th place, well below other countries where there is a very intense mining activity. It seems that now, even at a national level, in recognition of everything that was done here in Brazil, in order to create a situation where there's lower risk socially and otherwise in mining ores. This is a good place to begin those discussions, to realign the Brazilian practices to the international ones, and to find out what's best for each situation. I personally see no restriction to the use of, to the permitting of dams which are downstream raised. And at an international level, my opinion is a little bit different from my colleagues. At an international level, the upstream raised dams are still being built. I don't think we're going to do that in Brazil anymore, but they would be adjusted for plain zones, plain areas with low potential risk. I don't think this can be done in Brazil, but surely we can realign our practices in the coexistence, as Breno said, with of dams and stacks. This needs to be discussed by society. Well, we're almost out of time. There was a question here about... Oh, Sergio, please go on. Okay, I just wanted to add a little bit here to the discussion, but we have regulators and legislators which are going to debate that. What we need to be careful with when it comes to legislation is that sometimes they're written at a moment that's very emotional after dam breaks without a lot of communication. And this could be an element for the owners to run from Brazil, to avoid Brazil when it comes to that. It's been mentioned yesterday that we are now 6 years without any accidents. And we've talked about it with everybody. And we need to understand both sides so that we have something safe. That's the first priority. We don't want to lose lives or damage the environment. But we also want the owners to remain here in Brazil. If Brazil becomes too conservative or too strict, too harsh in terms of legislation, unnecessarily, the owners will flee Brazil. Okay, there was a question here which is about how you can control compaction, but I think Fernando already has offered an insight about that. We have 2 minutes left. I think we don't have more time to ask another question. And the MC already is giving me the dirty look. So now it's just a matter of thanking the panelists for their input and to Ibrahim for the invitation. And thank you for the audience for your contribution and your attendance. I also ask my colleagues to say their final words. Okay, I just wanted to say thanks to Paulo for being a moderator. Once again, to my colleagues, Sergio and Fernando. Thank you for the audience and Ibrahim for the organization. That was a very interesting discussion. Thank you. And likewise, thank you for the invitation. Thank you for the opportunity. I always leave here with the feeling that I learned more than what I offered, but that's the point, right? Of coming to those events. There will be a debate in the afternoon about legislation, and I hope that these talks can direct efforts to what is going to be discussed later. There's a lot of literature, especially in terms of guidelines in mining companies which are at an excellent level. And they support our legislation, our decision making. They encompass the design concepts, technical specs for procedures, planning, control, water management. These fundamental aspects are being really well discussed, and we tend to bring that to our own standards and best practices. I have 5 seconds left, so thank you very much, folks.
Thank you very much. I'd like you, let's take the official photograph, please. Thank you very much. We'll take a brief break and come back 10:55, please. Thank you.
Thank you, guys.
Quero fazer um pedido para vocês, assim que possível, fazer a gentileza de responder à pesquisa de avaliação do evento. É sempre importante a contribuição de vocês para que a gente possa melhorar sempre. O QR Code também está no verso do crachá. Nós teremos agora a palestra
We're going to have the Magna report, a theme, Management Institute. This is an update of the status of the recent launched and which will supervise the implementation and the compliance with the global standard of the industry in waste management, the GISTM. To chair, I'll invite the Global Geotech Director of Vale, Gerardo Paes, and our illustrious panelist, Emma Gigan, Director of Data and Research and Supervision of Materials Management of Tailings and Projects, Data Projects of ICMM. Please. Geraldo, we pass the floor to you. Good morning, everybody. Let's go to the second presentation of the day. First of all, I'd like to thank Ibrahim for the opportunity for the organization. We have discussed in this kind of event every day, every year we do it. For the number of people, we can see that more and more we manage to get a lot of public, greater interest of society. So I'd like to thank Giulio Aluni for the organization, the colleagues of the Dems. I'd like to comment as well. The idea is a little in the presentation. Let me explain why Emma came. When we were discussing if this theme of GTMI, we were discussing what would be the best format. Would it be a company or invite somebody? And we thought that it would be best ICMM had an opportunity to come here and talk to the public. There was great interest in Brazil about the Institute, and we have moved forward since the beginning. This has grown a great deal, and there's a great interest of the general public to understand how it works, what are the members, what is the scope, what are the limits, how to be part of the Institute. So we understood that better some of the companies or someone to speak would be ICMM, one of the co-founders of the Institute. Because Emma is, we'll tell her, right? Because I've just learned to Emma Gagan. ICMM has a way of working, has governance. We normally, all that was there, the work inside IBM was Aiden, and there's a transition now between Aiden and Emma. Emma is taking on this area. She takes care of projects, data, research, mine closure. It makes a connection with the way we structured it. Just to give you an idea, Emma will give a lecture. She has some slides. It was very didactic. I think it covers many of the questions here. When she concludes, I'll make a brief closure, bring a few points of view of Vale and something of the company and the industry, what we're discussing, and then we'll open for questions and answers. So then you know one of the questions. You can use the QR code. This dynamics will give us about now to have a lighter discussion about this. It's a theme of interest to everybody. Maybe we don't have all the answers at the moment. Emma will talk about. GTMI is being set up. It is set up. This get the public as maximum. With this, I invite Emma to the stage. Obrigado, Geraldo. Obrigado, Ibrahim, pelo convite. É privilégio estar no Brasil para falar sobre o Instituto de...
I've loved Belo Horizonte, and I'll have to come back for a longer time next time. Today, I'm going to take you on a journey. Some of it will be ICMM's role in tailings over the last 10 years, culminating in the Global Tailings Management Institute, or the GTMI, which I will just abbreviate from here on. But I'm welcoming questions at the end, so if you can use the QR code and post those questions, Portuguese or English, Geraldo will make sure they make their way to me. Would love to engage with you about any of our work and about the role of the Institute going forward, even at lunch if you like. Thank you. So I'm going to start with who we are, what our strategy is. We've just launched a new strategy for the next 5 years. And then I'm going to deep dive and look back at our tailings management work over the last 10. Some of that has been in the Global Tailings Review, the Global Industry Standard, and now the GTMI. And then we're going to deep dive on the GTMI and what that means for mining companies now. Hopefully there leaves enough time for questions around the GTMI or any of our work. Who is ICMM? We bring together about a third of the industry to drive leadership, action, sustainability in mining and metals. Our mining company members represented on the screen, 24 major mining companies, many of them sitting in this room, and they cover about 650 assets in more than 50 countries. We also have commodity or national association members, IBRAM is one, that share our vision for a safe, just and sustainable world underpinned by responsibly produced minerals and metals. It isn't possible to just say, I'd like to become an ICMM member, can I pay a fee? There's requirements, rigorous requirements and performance expectations of our members. And this is how we drive performance improvement at scale, that members commit to our mining principles. They're outlined on our website in 10 different areas if you want to see. And they have to be applied at site level, have a self-assessment process, and assurance and validation process that's externally assured on a cycle as well. And this then is how we see improved performance across the globe at scale. So you can drill into any of our performance expectations or the principles online. There's 10 of them there, and they go into a little bit more detail. The tailings-related ones are under principle number 6, which is where we also have our nature and carbon and waste management-related principles. Pretty high level at this stage to just design, construct, operate, monitor and decommission tailings storage facilities in line with good international practice to reduce the risk of catastrophic failure. A couple of caveats, and those two little caveats are that riverine and lacustrine disposal as a last resort. And the second caveat that we've also, members have committed to implementing the global industry standards, so the GISTM. But when there is a critical industry issue and members want to take a leadership position that's a lot more, in a lot more detail than something like a principle, we might make a position statement. And I'll talk about our tailings position statement in a minute. We exist as an organisation to support our members deliver on the principles. They might look easy when they're simple words like this, but operationalising that on the ground actually requires a huge effort at all levels of the governance chain in an organisation. That's what we exist to do. Capacity building in our companies, supporting peer-to-peer sharing between our members to help each other, and guidance development. Many of you will be familiar with our guidance development, everything from nature, safety, climate, through to tailings. And that's available well beyond the membership as well, so publicly accessible for even those beyond the membership. We've just embarked on another 5-year strategy to support our members' improve performance in the areas where we've made bold commitments, and our tailings work fits very nicely under this performance improvement pillar of our next 5 years. Alongside our work on decarb, safety, social performance and nature, it's one of the priority areas for our members for us to support members and for members to support each other in continued improvement going forward. Not just tailings management, however, you'll see it's also tailings innovation and looking at tailings reduction with the bigger picture goal of tailings elimination. Alongside our performance support work, we do have work on standards development. Many of you will have seen the proliferation of standards in the international reporting space in the last few years. We're seeking to consolidate and streamline those with our partners, World Gold Council, Mining Association of Canada, and the Copper Mark to see if we can denoise the standard space and have a single consolidated mining standard to support people focus their efforts on delivering against the standards rather than just reporting out against them. So that work runs in parallel to our performance support work. And then the third piece of our puzzle is the dialogue, engagement and advocacy work that we do. And I lead some of that work on data. I also lead some of the work on material stewardship, which is a pollution policy engagement work. So I sit across performance and our advocacy But happy to speak to any of the pillars of our work, or if you're interested in what we're doing going forward. Tailings, however, has been part of our journey since almost the beginning. I'm only going to show the last 10 years on this timeline here, but ICMM has been around since 2001, and it's always been a priority issue for our members. In 2016, the Council of CEOs, so the 24-member company CEOs represent our council, committed to articulating our commitments on tailings management in a much clearer way, in much more detail through our tailings position statement. And that outlines everything from governance, change management, risk management, the whole way through. And those need to be assured against, they're kind of additional to the mining principles that I showed previously. In parallel, 2 years later, the council thought we can't just, well, not just the council, but all of our members, and then council agrees to, we can't just talk about tailings governance and doing things well, but doing things the way we always have. We need to have a goal to cost-effectively eliminate tailings going forward. And so the tailings aspirational goal was launched in 2018 with the CEOs committing to, over the next 10 to 15 years, looking at ways to think differently. Can we reimagine how the industry thinks about tailings? And this, I think, is really important to keep in mind. We're here talking about tailings management, but I think we can't forget the opportunity for rethinking things, tailings elimination, and novel approaches, thinking outside of the box to the way we've always done things. A lot of work started in 2019 though, so that was our journey before then. Everyone knows Brumadinho happened in January. A month later, ICMM committed to developing a new standard on tailings management. In May, the Global Tailings Review, the independent process led by Bruno Oberle, how do we develop a global standard, went out for public consultation, massive multi-stakeholder approach, leading to a year later, the GISTM, the GISTM. And everyone in this room would be familiar with that. But that kind of catalysed the focus of our work for the next couple of years. How do we support members implement the 77 requirements in the GISTM? Part of that, and their commitment to disclose conformance with that. So our members had committed to disclosing their conformance with the standard 3 years later for extreme and very high consequence category facilities, and then 5 years later, so this August, for all the rest. Some of our companies, so Vale in particular, have gone well above that. They disclosed all of their facilities already in 2023 and are updating that much more regularly. But across the industry, by August this year, all of our members will be disclosing their conformance with the 77 requirements. And I hope later this year we'll have a bit of a summary of the snapshot of where we are collectively at the ICMM level against that commitment. But practically, to help people, we have been working with our practitioners on the ground to develop good practice guidance and the conformance protocols that support implementation of the principles in the standard. The good practice guide was written by tailings practitioners from our member companies and consultants involved in the process, and it covers everything from design, pre-design, like pre-feas stage, right through to closure, and governance through to engineering principles. It's high-level international guidance, the way all of our guidance is, so it has to be globally applicable, but it sets the standard for someone who needs to then operationalise that in their context. So if you're starting out or find you inherited a challenging TSF or an interesting governance situation in a new organisation, I'd say this is a place to start in terms of handbook of aligning against international good practice. It's still a really highly downloaded tool, well beyond our membership. The conformance protocols released around the same time support our members to adhere to the 77 requirements in the GISTM and auditors to confirm that. So that's been a really critical piece of work as well, and accessible to everyone. What I didn't want to forget though, the reason I've put it here is that in the background, while we've all been dedicated on helping people implement the GISTM, audit against it or check conformance with it, our work on tailings reduction and tailings innovation hasn't ceased. And in 2022, we released a tailings reduction roadmap, which is a bit more flesh on the bones from that aspirational goal of how we might actually move from just a nice concept of 10 to 15 years, eliminating or rethinking tailings to what are the critical enablers for that and what are the barriers that we need to overcome. This is a really interesting piece of work. And I've heard some of the themes come through in the conversations that we've been having in the last day and a half. Can we think differently, that it's not just a dam or a dry stack as our only two options? Could we rethink completely precision mining, precision separation, just even doing exploration differently, that's the kind of stuff that we explore in the roadmap. What are the barriers to completely and fundamentally rethinking the way we manage and mine our resource to kind of reduce the need for tailings, and where we can't, to think about ways to reprocess or find value from that waste. So that's where we have focused our efforts. In parallel, the United Nations Environment Programme, which I'll just call UNEP, and the Principles for Responsible Investment, which I'll just call PRI, who were very involved in the standard development and catalysing the process way back in 2019 and 2020, established an independent advisory panel to look at having a body or a home for the standard. And having this independent advisory panel do that was one of the recommendations of the Global Tailings Review back in 2020. But they just gave a bit of time for people to get used to the standard and thinking about that before we could put our minds to how we might have a long-term home for the standard. And so UNEP and PRI led this process with the independent advisory panel. 2 years later, they made their recommendations. They're not publicly available, but everything that I'm going to share today about the GTMI is effectively the embodiment of their recommendations. So you'll see it outworked in the next few years. But 2 years later, the independent advisory panel recommendations had come out, and UNEP and PRI announced that we're going to have a global tailings management institute to be the home of the standard going forward. 2 further years later, January this year, we launched the Global Tailings Management Institute. And I say we because UNEP, PRI and ICMM have co-founded this initiative, and it's been a lengthy process, very multiple stakeholders involved and very laborious to keep everyone on the journey to make sure we end up with an institute that reflects all stakeholders, that will be credible and have a long-term future. But I'm really pleased to say that it launched in January and we're deep in the weeds now of making sure that it's self-sustaining and functional. So that's what I want to talk about going forward, and really welcome questions on the GTMI. So co-founded by ICMM, UNEP and PRI, actually established or domiciled or incorporated, if you like, in South Africa. All the founding partners thought it's important that the GTMI have a presence in the global south. And so while it will be incorporated in South Africa, it's still going to have a multi-stakeholder board represented with global representatives. So it's not restricted to South African staff or a South African board or anything like that, but will have its home there. Will be independent from us as the co-founders, governed by a multi-stakeholder board. So that's our vision, to kind of remove ourselves from the process, that this institute becomes self-sustaining and the long-term home for the GTMI without the partners, ICMM, UNEP and PRI, needing to be involved in the day-to-day. It's the long-term vision, and one we're really excited about. The guardrails for the Institute to enhance the safety of mine tailings facilities, to promote widespread uptake of the GISTM, so it's very focused in its mission, and the bigger picture North Star, if you like, to zero harm of people and the environment, the same goal every one of us in the room has. But it's not, it's been very crafted to be very specific with its focus on GISTM and implementing that for the safety of mine tailings, to not lose focus over time. That's the guardrails which the Institute has been incorporated on. Its core function will actually be to manage an assurance framework around the GISTM, and not just an assurance framework. So at the moment we have conformance protocols and members self-assess or get third parties in to assess their conformance against it, but to have a credible process where independent auditors who've been certified by a mechanism that the GTMI will establish to check conformance with the standard, to give credibility to somebody's claim that they are in conformance, and to ensure that there's rigour around that process and consistency. So this is their core function. On the side, they'll also be raising awareness, supporting wider industry uptake of the GISTM and knowledge sharing, and participation companies and consultancies, that kind of thing. But their primary mission, really that assurance framework and credibility around the standard. Important for me to mention that GTMI is a not-for-profit organisation, so there will be a fee structure for people to, or for companies to become a signatory and participate in the GTMI, and it's intended that that not be an inhibitory fee, but just to maintain the GTMI over the long term, and I can talk more about that later if people have questions. But it would be not-for-profit, governed by an independent board, as I mentioned later. And I had hoped to be able to give you an update and say the board had been announced. We're waiting for an announcement of the board finalisation last week. I think we've still got a few little more things to iron out, but please keep an eye out for that. It's very imminent that we have been able to shortlist some candidates from 9 stakeholder groups, so mining industry, affected communities, Indigenous peoples, finance, banking. You know, it's really important, or it was really important to us as the founders, and a clear recommendation from the advisory panel that this institute have multi-stakeholder voices at the table from the outset. And so that's something that's taking a bit longer than we had hoped, but is really fundamental to the long-term success. After the board is established, the key executive positions will be in place. So we are in recruitment at the moment for a CEO. And as soon as the CEO hits the ground, I think we'll hit go on a technical committee being recruited as well. And the technical committee will oversee elements of tailings management that are a lot more technical in nature, whereas the board's strategic direction and oversight, technical committee might, for example, look at conformance protocols or things where advice is sought on interpretation of the standard, things can be referred. So those 2 kind of governing bodies are to sit alongside the executive positions. As I mentioned, board establishment still in progress. I had hoped to say finalised, but nearly there. CEO recruitment happening, and the technical committee will come later in the year. So please keep an eye out. You can register to receive updates via the website. If you're interested in applying to become a member of the technical committee, we'd welcome your application. We've seen really great representation from Brazil amongst the applicants for the board, and it is genuinely important to us that we have global participation in the Institute and in its governing structures. So consider applying for the technical committee. If the CEO deems it necessary, there's a CTO role that will come later as well. And soon after that, the call for signatories to the GTMI. To become a signatory, there'll be some formalised process probably announced on the website, but it's really a public commitment to conformance with the standard and to continuous improvement in tailings management and the transparent disclosure of auditing outcomes that comes with the GTMI. This is really important because it's possible for any one of us to claim we're conformant with the standard, but how do we give our stakeholders, how do we give our investors, how do we give our insurance brokers confidence that we are actually in conformance? That's kind of the origin story of the GTMI, that we would have a clear auditing and assurance process and disclosure of results so that public can scrutinise them. And so becoming signatories, committing to those things, and the GTMI, all of the co-founders genuinely believe this will improve the social licence to operate relationships with regulators, investors, and insurance brokers in particular. But more than happy to talk details to people about becoming a signatory later if of interest. If you're not a tailings operator, but you're still interested to support the GTMI, this would also be amazing. Please register your interest as a signatory. And these signatories are entities that are really interested in fostering knowledge sharing, continued improved performance, capacity building, and other of the ancillary elements of the GTMI's function. So we'd really welcome participation from anyone in the room, whether you're an operator wishing to sign up as a signatory or a consultancy wanting to become a supporter. Please be engaged. We need Brazil in this process. In fact, Brazil is leading the way on many tailings initiatives. We've seen it here, but I've seen it firsthand through the site visits that I've had in this country. We need Brazilian participation in the Institute at all levels, so really encourage that. That's it for now, and I hope I've given enough to give you some time to write your questions in the app. But just to remind you, tailings continues to be a core part of the work at ICMM. Together with UNEP and PRI, we have founded the GTMI. That's one part of our work. We continue to support practitioners with performance improvement and the tailings reduction and tailings innovation initiatives that are ongoing. GTMI itself exists to ensure uptake of the GISTM and assurance against that framework, and it will have a system in place for auditing, accrediting, becoming a signatory very soon, so keep an eye out. Recruitment of the board and the CEO, etc. underway, announcements imminent. I hope to be able to give you more details very soon. I think that's it.
Esperar uns minutinhos aqui para ela colocar o headset. Enquanto ela coloca aqui, só fazer um reconhecimento, né? do esforço, né? A EMA ela veio.
Emma comes from Australia for this 2-day event only, so I just wanted to recognize her effort and the effort the ICMM goes through just to, tell us a little bit about their work. She's still a little bit jet-lagged. It's a short, it's not such a short trip. She needs to get some good sleep. Otherwise, when she goes back, she'll still be jet-lagged. But I hope it's all worth it. I just wanted to say thank you for your presentation. It clears up, it clarifies a lot of the points that we were talking about. It at least gives us a good overview of what, apart from what we've seen in terms of publicity in the media. I noted a few points just for reflection. And we're discussing internally and with other people some reflections on my part, on Vale's point of view. First, the GTMI, the way we see it, is a fundamental step in this process when it comes to having a more robust tailings management, a more reliable and more transparent. Basically, that's what we've seen now in Emma's presentation. In Vale, what we've been doing is, since the beginning, as an ICMM member, from the very beginning of the discussions, then we got JSTM, we have an institute with the other co-founders as well of the JSTM. How could we materialize? We began a very difficult debate saying, if you have a JSTM, JSTM is a standard, it's a volunteer standard, but it's self-declared. I think there were two big questions there. Well, how do we bring more credibility for those companies that are self-declaring? And the second was, how can we make sure that the standard, everything that stems from it, is going to be sustainable over time? Because one of the important points in the beginning, one of the co-founders' point, was to sustain it, but we know that any kind of standard can be improved over time. And how is this going to happen? Are the co-founders going to sit down again, going to ask the public again? If you saw the creation of the GISTM, it's very robust, but every time you're going to improve it, it will be very hard. The idea of the Institute is a very happy one because it ensures the continuity. Now the Institute is going to oversee the standard and the application of the standard globally. I believe that this is an important point. Vale has always supported this unconditionally. And of course, there's a structuring process, formalization process, just as Emma showed us. There's a board, there's an executive and director board, but we made good progress this year. And third, Brazil. Not only Vale, but Brazil. How is Brazil doing? What we've seen is Brazil, we talked about it. You saw yesterday's presentation from Paniago and Roberto's. Because of legislation issues and new legislation, Brazil made good progress. And by applying legislation, we managed to consequently make good progress in our practices and governance. Naturally, the cutting-edge companies in Brazil, they are in a good position to implement GISTM. And we saw that in Vale, as well as other companies that are part of IBRAN. And we know that perhaps, I think Brazil is in a good position. There is a lot more work to be done. And this is a journey. Brazil is in a good position, in a good place. We need to recognize this. The fourth item would be, and this is just to highlight what Emma said in regards to GTMI. Unlike ICMM, which has members, GTMI is open, so the companies can become signatories, they can be a part of it, and I see a great value in that. For the companies that have access, and they're going to have more credibility, they're going to be accredited, but not only that, accreditation is just a part of it. If you're part of the community, this brings you to a more high-level debate, but this is the testimony of what I see. I have a technical and institutional role due to a number of reasons, but I really talk a lot with investors, the insurance companies, communities, government. And what I've seen in the last few years is much more attention of the stakeholders on the GTMI. Invariably, when we have meetings with investors or valuation companies or risk assessment companies, half of the questions are related to GSTM, how Vale is overseeing that, how they view that, how they're applying it, what are the challenges, how compliant we are. So half of the questions are about that. There is a great appeal to them, and as I said, the insurance companies too. I think we're going to have increasingly more as the ICMM and GTMI structure themselves. There's going to be a contract eventually. Governments, agencies, they have used increasingly more the GSTM to perform the assessments, complementing those other things which are important. The clients, I've talked to clients, some clients, in order to sign contracts, sale contracts, they're asking about that. They're going to go, well, I'm buying from you, but you got to tell me what's your management like, how you're doing that. Are you compliant to GSTM? How you're doing in regards to that? That's the appeal I make to the companies. The companies are structuring themselves, but they're not yet formally signatories, so prepare yourselves to do that. That's the kind of commitment that's going to pay off in the future, in the long run. I talked about all the stakeholders, but there's also the community. As we debate more, the communities are going to organize better, they're going to get more sophisticated, they're also going to ask about that. So it's important that the companies are also prepared for that. And the fifth point is, well, we saw the structural bit. You know, it's not all good stuff, good news, but it's a new system. It's a standard that's only 5 years old. We know that there will be audits that are going to be accredited, and there will be the need to adjust, the need for more debates. We've talked a lot about the ICMM in order to try and organize that, but the Institute needs to be always open to dialogue. It's going to be necessary to adjust, to debate. That's why it's important for us to have a multidisciplinary board with a broad overview and foresight so that we can be open to dialogue. We know adjustments are going to be needed. And something else that we're talking about, I was talking to Emma, Ibran always mentions that there is an evolution. It's not a straight line. Doesn't mean that it's straight. You have highs and lows in the process, but the trajectory is ascending. That's how I see GSTM and GTMI. So I think we need to recognize that there will be points that will need discussion, but we are open to dialogue with everybody, and I think we're going to be successful. And lastly, I'm going to make an effort for everybody to engage. As I said, there are companies, but there are also other entities that could be signatories, or they could also support GTMI. As we structure GTMI, or it structures itself, things are going to be more clear, I believe. The executive committee and so forth. But on LinkedIn, you see a lot of publications being posted too. If you don't know about it, there's a newsletter available. You can sign up for it. Just use your email. And you can rest assured that Ibran is also going to be included in that discussion. These were the main points I wanted to discuss. And we've got another 27 minutes. We've got a lot of time for questions and answers. Thank you very much. I'm just reading. I'm trying to select the best question. There are so many questions.
Might mention, we never intended the fee structure to be prohibitive. I mentioned that in my talk. And the fee structure will be formalised by the board, of course. The founding members and the independent advisory panel have made some suggestions and recommendations. But small companies, big companies, there will be a differentiation. It's not a one-size-fits-all. And size of company might just be how many TSFs you have, not your market cap or your production volume. And so we really intend that even if you just have one TSF, it's still possible to become a signatory and the fee would not be prohibitive there, and large companies would be in kind of a different category. So still would encourage, even if you consider yourself a small operator, to not think the GTMI is not for me.
Uma pergunta aqui que veio até separar.
That I found asking about how can we be a part of GTMI or engage more with GTMI. We know A&M is there, but any other public body, either government or NGOs, what's the pathway that you have for those entities? Ótima pergunta. Quanto o GTMI se tornar
communication and dialogue. So this has been something that's fundamental from the incorporation, and even in the independent advisory panel recommendations, that there be that dialogue that Geraldo was talking about. So part of that comes through mixed representation on the board to see regulators at the table, but part of it will be proactive, and the GTMI actually going to engage with regulators to ensure that GISTM is incorporated in their regulation, and to hear whether that's town hall, community forums, or individual country by country outreach. It will be up to the board to decide, but it's very much front and centre that they don't operate in isolation and continue to have dialogue with regulators, insurance, investors, the really key interested parties. So while I don't know what it looks like, rest assured that it has been key in the decision making and the principles through which we've incorporated the Institute. And I should say that once the Institute, or once the board is formalised, the Memorandum of Incorporation, which outlines in a lot of detail what the Institute will and won't do, and the charters are relating to the technical committee and their scope as well, will also be publicly available. So this information should become clearer too when those documents are available. But yeah, welcome proactive engagement from anyone wanting to be involved. Like, even if you just put your name down on the mailing list at the moment, and we keep it as a placeholder for when the CEO is in place, but also be ready for the GTMI to reach out, because they will be doing that in all jurisdictions around the world.
Found out why it took so long to find the questions, because they were in the previous section. Now I found them. Let me scroll through here. I'm going to ask the organizers to give me a hand, because everything is clustered together. Just I want to find the questions for this session. A lot of questions about flood maps. This is not for this session, I'm sure. Oh, now I see them. Thank you. The problem solved. The problem is the operator, not the tech. So here's the question. How does GTMI and GISTM intends to assess the tailings disposal in pits and stacks, not in dams?
That's a great question as well. So at the moment, nothing is out of scope except for riverine and lake-based disposal, as far as I've seen. So if you consider it to be a tailing storage facility, it would be in scope. And if so, the same way that it is under the GISTM, we have members at ICMM that would see maybe not all of the 77 requirements of the standard are relevant for in-pit disposal, but they choose the ones that are relevant to ensure they're conforming against them. The facility just doesn't have a consequence category, a classification, for example. So it's not, if you consider it to be a tailings facility, I would encourage you to still be applying the GISTM, even if there's no consequence classification at the end. It doesn't mean that the other requirements of the standard are not relevant, and those can still be audited and assessed if wanted, if desired. I hope that answers.
Yes, it is. It's a very common. Uma aqui, como deve ser o processo?
How should the process of assurance be? Could you ask him to repeat it?
How's the process for the accreditation?
Has been envisioned so far. So the
A forma que
GTMI
foi
will
visto
oversee
até
the assurance
agora,
process and
GTMI vai ver o
accrediting auditors
processo
via a
de
certification
auditoria
scheme.
para um esquema de certificação. Tem alguns modelos e padrões que poderiam ser utilizados como referência, porque é a forma que nós temos garantia. Muitos membros estão fazendo com protocolos no momento. Esse relatório detalhado vai para a empresa. A apresentação pública não é tão detalhado, mas é alto nível. Se alguém está interessado, o nível de atendimento de compliance, o auditor fornece isso, está disponível no site, as recomendações.
Has that answered the question?
Yes, I think so.
What was the experience of ICMM engagement of suppliers and other players in the mining chain as supporters? What is expected from the supporters?
So far, we've had really good engagement in the process, not just in the standard development, but in the consultation, so through the independent advisory panel recommendations on the GTMI. There has been extensive engagement at all levels of the supply chain and the stakeholders, as far as I understand. So that's why the process has been slow and lengthy. But going forward, I think we have no limitations on who can become a supporter, and would really welcome downstream suppliers, upstream, anyone that shares our vision for zero harm for people in the environment from tailings facilities to participate. Some examples of what that might look like could be hosting a roundtable for knowledge sharing in your region, or communication and outreach about the GISTM, things like this. I don't propose to be the board and to say exactly what it will look like. The idea of the GTMI is for it to be independent and have its own life. So once the board is in place, it might look different than what I'm sharing today. But these are some examples of things that we as the founding partners have talked about, how supporters can be involved, and who they are is not limited. Whether you're a supplier, whether you're... It's just the distinction between a supporter and a signatory is just whether you're an operator to become a signatory or not an operator. So no restrictions over there if you're a supporter, and you can provide that ability for capacity building, knowledge sharing and outreach about the GISTM, please be involved.
A gente fala muito de timing aqui, tem muita...
We talk a lot about timing. There's a lot of demand of questions for timing. This, in a way, it touches this. When the certifying companies be accredited by GTMI?
Sorry, when will they be in? Fantastic, great question. I'm not actually sure if there's a time frame on that, but it is a key, it's like one of the first things that the board will have to do is establish the certification framework. As I mentioned, there's some templates based on other organisations that have done similar assurance and certification schemes, so we don't have to start from scratch, but this is like the first or second thing that the board has to do is start establishing the certification requirements and providing the framework by which people can become accredited. So I don't know the time frame, but I would say one of the first or second things that the board is responsible for delivering. So if I think about the timeline where we are now, board, CEO later in the year, technical committee by the end of the year, I imagine the call for signatories be early next year, and I think at the same time the accrediting process will already be well in train. So if you're looking to become accredited or to be an assurer, I'd say keep your ears out towards the end of this year, early next year, as to what that process might involve. That would be my thinking.
this point, which is commented, the companies that thinking of budget, what will it be like next year? Do I put my budget in? Do I put it in the budget or not? At least we include it in the budget for 2026, the provisioning to do, depending on how the schedule, you can go to a part of 27, but one way or the other, we're planning that it will happen in 2026. Speaking from our side here. Another question. GTMI, will it have autonomy to do adjustments, alterations, updates in GISTM? Pergunta como.
We, as the founding partners, want the GTMI to be independent. That ensures credibility of the standard and the assurance process, and this was really important from the beginning. However, we made sure this is in the Memorandum of Incorporation. If the Institute wants to change the standard, the partners are not far away and need to be involved in the process. We saw how difficult it was at the beginning to get alignment on the standard in the first place, and the last thing we want is for the Institute to take the standard in a direction that wasn't intended based on the Global Tailings Review and all of our input back in 2019 and 2020. So founding partners won't be far away and will need to be engaged if the standard needs to be modified, but for all intents and purposes, we want the Institute to function independently for all of its other activities.
As we discussed, it's important to have an agency that does this management. Otherwise, you have to go to the cycle and full mobilization, as was done at the beginning. Another question, Emma. From the cultural point of view, GISTM has environmental, social, and technical requirements. In this context, how do you see they should be the ITRBs? How should they be made up?
Great question about the standard rather than the GTMI specifically. Love this question. I'm a closure practitioner by training, and so I've always felt that ITRBs need to have some bit more broader perspective than just the engineers, so I've loved this debate over the last few years. But it's really what your facility needs, and you are best positioned to know what expertise you need and what composition on that panel, so we don't try to mandate a one-size-fits-all, a minimum diversity on the ITRB or anything like that. We really trust the operator and their accountable executive to make sure that the composition of that board reflects the needs of and the risk of that facility. But I would personally encourage diversity in terms of people with social competencies, people with the environmental and even the closure competencies to have representation on ITRBs. When we think about GTMI, it's not trying to take away from engineer of record or ITRB or any of the things that we're already doing as part of the process. It's just about assuring against the requirements of the standard to do those things. So those won't change. But thank you for the question on ITRBs. Encourage diversity, but make sure that the composition reflects your risks at your site.
Let me just add to that, not too much to do with GSTM. There's an old discussion, you participate in conferences and discussions. I think this is reduced a bit. Maybe sometimes I see a debate saying what is more important, is the technical part or the governance. In fact, they're both. One doesn't live without the other. You have to have both things. It's a debate that shouldn't exist. Technically, governance supplement each other. So when we say of reflecting for this question of ITRB, that's it. You have the technical side in ITRB. You have to have, but you also have the members of ITRB understanding governance. One thing doesn't work without the other. How is it possible? Another question. How will it be possible to ensure a compatibility of the existing procedures to meet local legislation and the requirements of the standard of GISTM?
Eu acho que essa é uma pergunta que o GTMI vai.
I think it's a question GSME is it that GTMI will think a lot about when they begin their work, I guess.
Yeah, thank you. The GTMI not seeking to change the standard nor to change regulation, but to make sure that there is awareness of both and that open dialogue that was talked about earlier. So there will be proactive outreach to ensure that regulators are understanding the GISTM, seeing where it can be incorporated in their legislation, but welcoming that feedback on where there may be opportunities or things that need to be tailored for particular jurisdictions to ensure that there's open dialogue and communication. So we would encourage participation from regulatory bodies, and I'm pretty sure that GTMI will be doing that proactive outreach as part of their early works in the beginning as well, but not seeking to be a regulator or to be a legislator. Narrow the guardrails of the GTMI very much around the standard, but ensuring there's mutual understanding between all the parties that need to understand about it. And that would be regulators, that would be stakeholders, that would be industry as well.
Since we have a little time, I'm going to get away from the theme of GTMI. It's linked to GSTM, but it's a very specific question. In the question of closure, you have any example with your experience, example of cases of success for dealing with tailings?
I've seen across the membership a number of, across the ICMM members, a number of examples where safe closure, but via the standards definition, has been achieved. So ITRB signing off on there's no risk to people or the environment. But when I think about closure, I think about much more than just having an ITRB signature. I think about post-mining, the life, the transformation of that site into something that's completely different. And I think we see here in Brazil some really great examples. Some of the work that's happening in Brazil with decharacterization is completely eliminating the properties of a tailings facility and giving that area, that footprint, a new lease, if you like, a new chance for a completely alternative post-mining land use. I think we haven't seen so many examples yet where the post-mining land use and the new future or the new life for that footprint has occurred, but I would say we're starting to see some really encouraging examples there. And as far as most of the people that I talk to see safe closure under the GIS team as kind of a first step towards that then subsequent land use and the exciting possibilities that closure actually can bring for a TSF. Yeah.
There's another question which is a follow-on. How does ICME see circular reprocessing of tailings in the future of global mining?
There's a huge body of work on circularity at ICMM, and we last year launched our Tools for Circularity, which has some fantastic case studies, including some from our members here in Brazil around repurposing, reusing, valorising waste, not just tailings, but a lot of it is tailings. I think this is an emerging issue that none of us in the room, not just ICMM members, but none of us can afford to be ignorant about, because ore grades are decreasing everywhere. Sometimes our tailings deposits from the last 40 years are now much more enriched than new deposits we could find. This is going to be the future of mining. And so we see this as a really big area, but not one that has necessarily technological challenges that need support. So one that we already see a lot of innovation happening, a lot of leadership from our members, and they're well on the road to embedding circularity in their thinking. So it isn't one that's like a priority topic for us, as much as we want to create the facilitating environment to, as I mentioned, overcome the critical barriers and amplify the enablers to see this happen at scale. Some of those are regulatory barriers, very few of them are technological, as I mentioned. So yeah, really looking to support our members overcome those barriers to do what I think we all know we can do when it comes to circularity and reprocessing. Where there is an opportunity for valorisation, like metal recovery, for example, from tailings, we've seen some cool, really cool initiatives. I think Vale is leading a few in terms of reusing material for bricks, cement, road bases, those kind of things. I think there's a few ways to think about valorisation, and we shouldn't just limit ourselves to thinking it's about metals, because that's how a lot of the world has been thinking about circularity and remining tailings. It's been about metals. As Vale is showing, it's in the iron ore industry as well. We can still create value from our waste streams. So that's probably what I would say about circularity. Happy to talk more, not just on the waste side of things, because circularity is also on the other side of things about preventing waste generation at all, but happy to talk more about that in the break if anyone's interested. And I would encourage you to check out our Tools for Circularity, which has some really great examples there for our industry.
E para complementar também, tem uma uma iniciativa dentro do ICMM, né? Tem grupo de trabalho
that looks at tailings reduction. So it is very far-reaching. You work with both ends, reducing generation, but working also on what was generated, how you manage to reduce what already exists and reprocess it in some way. It is a great initiative in ICMM. It's not something that you can solve quickly. It's a long-term, but at least it shows the way we could already find a solution. There's the economic side of things, but more and more when we extend this equation to the social, environmental side of things, it makes more and more sense. It's an important discussion. Now, changing the focus a little, this question, let's see how you're going to answer this one. In your opinion, how can GTI help the companies to be more able to help in a crisis situation which involves the continuity of the business? It's part of the very principle of GSTM, or the requirements. If you could just say a little bit more about your view in this requirements of GSTM.
The requirements of the standard, or or how GTMI will?
How the GSTM helps to face some crisis management.
Yeah, I think we went through a really lengthy process at the beginning, and particularly in response to Brumadinho in the development of the standard. So I think everything that is articulated in the 77 requirements, I think, is what we would consider international best practice in terms of crisis management and crisis prevention. But I would also encourage people to check out the Tailings Management Good Practice Guide and some of the articulations there around the processes that are in place, the governance that's in place, the preparedness that I heard in the panel yesterday talking about how we do the training with our communities, how we ensure that they stay engaged in those kind of processes, that it doesn't just become routine. I would encourage people to check out Tailings Management Good Practice Guide to think about operationalising the principles that are already articulated in the GISTM. I think, as far as I am concerned, they're robust and they're what we need to hang our hat on, but I would welcome conversation in the break if people feel that there's areas that need to be strengthened there. I'd love to hear your insight in that. Yeah.
Quando eu comentei,
Let me just add here, when I commented the points that Brazilian legislation has moved forward, when we compare it with, and we talk to the peers internationally, we see this is an area where legislation has moved along, where we're better prepared for these discussions, for these talks. You have a legislation which is robust with regard to the companies getting better prepared, but it can always be improved and discussed. I think this is a theme that Brazilian legislation and the norms have helped more and more the companies at this point, in spite of there's a long way to go, as we saw in the panel yesterday about this theme. One more question. How is GTMI involved in this with MAC, TSM, World Gold Council, Coppermark, ICMM, about convergence of global standards?
Yeah, thanks for asking about the consolidation effort. So for those that aren't familiar, we have been trying to align our standards, ICMM standards, with World Gold Council, MAC, TSM and Coppermark. There are quite a number of performance chapters in the draft standard, and I hope everybody had seen the consultation that went out last year. In the tailings management chapter, there's reference to GISTM and or MAC, TSM. But there's a note to this chapter may need to be updated when the GTMI becomes fully functional. So that's the latest I can share in terms of how we're thinking about what the GTMI, MAC and GISTM all have to do with the consolidated standard going forward. So it's kind of a placeholder to see how we can articulate the wording when the GTMI becomes fully functional and the home of the standard that the consolidated standard is referring to, if that makes sense.
I think we have time for one more question. They're very good questions. Last question. it will nicely close off our discussion. What's the world panorama overview of signatories of GSTM? What countries have more mining companies complying to the standard or signing up to the standard?
Oh, that's a great question. I actually don't know the distribution of countries at the country level of who has and hasn't committed to the standard. But later this year, we will be doing a progress report on at least ICMM member companies and disclosures by country. So I anticipate being able to have more information at that stage. We don't anticipate there being any kind of focus on one part of the world and not the other part of the world, so I would fully welcome participation in every country, even if there's one TSF in that country. So I think that's how we're thinking about it at the moment, rather than looking at the countries that have the most or have the least. It's a corporate level commitment to all of your assets in all of your countries, and that's how we would encourage it, particularly with the fee structure as well around small companies versus large companies, so few TSFs versus many TSFs. We really hope there to be global uptake, genuinely, yeah.
Well, I tried to cover all the questions, at least those that were more linked to the theme. I thank you once again, Emma, for this coming here, participating and talking about the view of ICMM, about GTMI. This connection is important to have more and more the view of what is happening. And I think now we close, right? Thank you very much. It's time for lunch. We'll take a break till 2 o'clock. I ask, please, to come back at 1:55 and ask, since we're going to have 2 hours lunch, who knows, we answer the assessment. QR code is on the back of your badge. 13:55, we're back.
bem-vindo ao Centro de Convenções. Seja bem-vindo ao Centro de Convenções da CDL-BH. Veja agora algumas informações sobre nossos espaços e conheça todo o conforto, modernidade e segurança que oferecemos. Para seu bem-estar, o ar-condicionado foi programado para deixar o clima aconchegante sempre a 22 graus. Em caso de incêndio, nada de pânico. Temos extintores estrategicamente posicionados e saídas de emergência sinalizadas. Em caso de queda de energia, luzes de emergência se acenderão automaticamente, guiando você para a saída mais próxima com total segurança. Pensando no acesso, este moderno espaço foi projetado com rampas, elevador e plataformas de acessibilidade para possibilitar a circulação de todos. E para que sua experiência seja completa e agradável, neste espaço é proibido fumar. Também estão proibidos alimentos e bebidas. Não esqueça de silenciar seu celular. A CDL-BH agradece a sua presença e espera que sua experiência seja produtiva e memorável.
Quando o futuro de uma obra depende do que está embaixo do solo, é preciso confiar em quem entende cada camada da terra. Desde 1985, a BVP transforma desafios em soluções que sustentam grandes obras. Ao longo dos anos, nos reinventamos e crescemos, gerando valor nas relações que construímos. Com inovação e rigor técnico, garantimos segurança operacional e otimização de recursos para nossos clientes. Criamos soluções integradas em geotecnia e hidrotecnia que transformam a engenharia. E assim, lançamos as bases do futuro com os pés firmes neste terreno. BVP, construindo relações de confiança.
Boa tarde.
Good afternoon. We are back. Please take your seats so we can resume our sessions. Please kindly take your seats. This is the second half of the day with the Tailings Brazil 2025 seminar. Now, during this afternoon, we will see another 3 panels. And let me remind you all that questions can be asked by means of the QR code on the back of your badges. And as we all agreed, I believe you all have taken the survey. In case you have not yet, please kindly do so. On our 6th panel, we're going to approach the topic monitoring of tailing structure and its importance to risk mitigation. And in order to moderate this panel, I'm going to invite the Senior Environment Manager for Tailings Management, for Dams Management at CBMM, Marcos Antonio Lemos Jr. Our panelists will be the Business Area Coordinator for Pimenta de Ávila, Marcos de Ávila Pimenta Filho. As well as the Vice President of the Brazilian Dam Committee, CBDB, Teresa Cristina Fusaro. I will now hand the floor to Marcos. He will conduct this panel. Please, the floor is yours. Thank you. Good afternoon, everybody. I'd like to first say thanks to Ibram, represented by Giulio and Nalini. Thank you for the invitation to be a part of this event. This kind of event really adds value to us in the technical community. It's time to see old faces, to share best practices, all of this to add to our safety. We've been making good progress in terms of safety in our processes. We see processes being developed with more technical content, more details. There's a very strong effort from the companies and the mining companies as well as the designers to get to know better the materials that we work with, on behalf of safety. But it's also important that we are especially careful when we implement that in the field, and that's how we connect that to our work in this panel today, how we assess performance after this work is done. Something that caught my eye yesterday during Caio's presentation was the question he brought to us. Without information, we're just another opinion. Everybody's opinion is important, but a good opinion based on technical data, based on evidence, adds more value and brings more safety to our processes. Well, our panel then will address monitoring of tailings disposal structure and its importance to risk mitigation. At the end of the day, we all work in order to bring more knowledge, to add to our knowledge, and to add to our safety. That's what the community expects from us. That's why we're here. Our panel will be comprised of 2 moments. We will have Marcos' presentation first and then Teresa's, each one talking about their experience. And after that, there will be a module with your questions. It's important that you ask questions during the presentations so that we can explore the topic further. I will hand the floor to Marcos now. Good afternoon, everyone. First of all, thanks to Ibram for the invitation, the opportunity of being here. It's a pleasure to be here in such a relevant event, addressing such important topics to our industry. We have prepared a presentation to address the evolution of monitoring of tailings dams along the years and decades, directed to the mining industry, separating the approach between a first moment where we are considering the past until the present, and from the present until the future. As I've shown in the first slide, we separate those periods. We do that on purpose with milestones that we are all aware of, such as the Brumadinho and Mariana accidents in 2015 and 2019. They represented very important events, and they are watershed moments in our industry, both when it comes to regulation with best practices, and as well, specifically with monitoring. We have split up this presentation into this structure in the 3 pillars: legislation, standards, and norms in the first part, and in the second part, operational practices and new applied technologies. First, I'm going to go over legislation, standards, and norms, not aiming to go too deep into that topic, because this should be done in the second part of the presentation, but we think it's important just to brush these 2 topics and to talk about the evolution we've seen along the last few years and decade. Beginning with legislation, we have a few milestones when it comes to regulation along the last years, beginning with the National Dam Safety Law 12334 in 2010. Later, we have an ordinance and a few resolutions. I'm going to go over them one by one. In the domain of monitoring only, initially, the national law from 2010 was pretty vague when it came to determining guidelines specific for monitoring. All it did was the definition, was to provide a definition of the need for monitoring and a manual for monitoring procedures. Right after that, under the domain of the mining industry, we have Ordinance 7389, which defines the need for implementing a monitoring system for dam safety. And in some specific cases for maintenance of monitoring with real-time maintenance, real-time monitoring, without any demands on automation. It also defines the need for the monitoring system information to be available for the civil defense at the NPM without specifying too much, as well as the need for specific cases of maintenance of 24/7 video monitoring. After that, in 2010, we got ordinance or resolution number 13 from A&M, which updates the second requirement that I just mentioned, but now specifying the need of a automated monitoring system for the instruments. An important step in the progress in this topic. Now, moving on, there were other ordinances, 32 and 40, but without any relevant changes when it comes to monitoring. In 2020, the national law, now federal law 14066, which changes, updates 12334, now adding the need for an emergency response plan to include a monitoring system and dam stability control integrated to the emergency procedures. And lastly, in 2022, Resolution 95 from A&M, which by chance is now being object of more debate, another revision, which updates those requirements in case there's a need for automated system for monitoring. Now it needs to be more encompassing, and as well as redundancy in the power system. In case of sharing the information with the entities, now it needs to specify specific data from the instrumentation. And for the first time in the regulatory framework, for specific cases, the requirement of geotechnical monitoring centers in some cases. Now, after we talked about legislation, let's talk norms and standards. We're going to quickly talk about NBR 13028. It is a twin of 13029, like a mirror almost, but we're going to focus on 13028. They're very similar to 29. It's just difference is that they deal with stacks and waste dumps. We're going to use 28 as example. It suffered a few revisions along the time. Let me point out the first one of them, 2006, which requires the installation of instruments and determines a few specific parameters that need to be monitored, like internal drainage flow rate, water levels in the embankment and the foundations, to define range for tolerances in the instruments, always bound to specificity. Under the NBR domain, there was not yet an approach according to failure modes, and the operations manual was also required, including monitoring requirements. November 2017, an update of the parameters, which now includes the pore pressure measurement, and it's important to determine ranges or reference levels based on potential failure modes, which is what we know is the best practice. And now, more recently, November 24, another update, small detail that the new parameter to be monitored is the water level in the reservoir. After legislation, standards, and norms, we wrap up this first part. Going into the standards, we have a lot of standards, including in the previous panel, they were mentioned. We don't have time to go over all of them right now, but what we'd like to point out here is that once the most relevant ones are listed in this table. The main aspects that we see in terms of evolution of monitoring and the standards, usually international ones, which are going to provide support to the best practices in our industry. Ideally, these are approaches in terms of risk management, governance, and corporate responsibility. The use of new technologies, a few of them are specified here: remote sensors for acquisition of automatic data acquisition, digital systems for integrating data management, analysis in real time, proactive and predictive monitoring. And lastly, here, perhaps going into the governance topic a bit more, but still closely related to monitoring, I made it a point to highlight the performance-based risk-informed safe design, which is included in the best practices guide from ICMM published in 2021, just updated recently in the GISTM context published in 2020, as it was said recently, with a timeline shown by Emma. And then, given the importance of this method, this approach, even though under the domain of governance, but connected to monitoring, we just wanted to make a quick note here to review what's this approach, and later resume this topic connecting this approach to new technologies. This approach comes up with more momentum by means of Professor Morgenstern and Victor de Mello, where they propose a method that basically is made up of a set of proactive measures for performance management and safety. In this same occasion, he proposes the ICMM to adopt those practices, and this makes it easier to encourage the signatories of the industry to apply this methodology. This was complied with, this recommendation, as it was said in 2021, the best practices guide was published, and the base and the foundation of the guide, one of the main ones, is the performance-based approach, which, as I said, is made up of proactive performance-based management based on sequential verifications or regular ones, which are continuous along all of the stages of a tailing structure life cycle, as well as continuous validation of design assumptions, and in case they are not validated, analysis of the decisions made in the sense of changing the route if it's needed, based on monitoring data, field data, investigations, surveys. This system is fed and fed back in a way that the model is constantly up to date and at any point in time during the life cycle, so that the new updates and validations of performance are made. Always assessing the present but projecting the future. This is the base of the performance-based approach, and connecting that with monitoring, the highlight here is an important aspect. It only works because you have the new technologies, both in terms of modeling as well as monitoring. It is also dependent upon a very efficient monitoring systems, preferably real-time or almost that. So now let's go back to our little timeline for this presentation. These are some aspects of operational practices. This is where we open up to a field that's usually not talked about in books, but it's very practical that we see in our routine. In this first case, we see people participating directly on the monitoring of the structures that we've seen along years and decades. Initially, in the facilities, even the biggest ones, the team was very small. In this case, you can see a guy who is responsible for measuring. He's called the measurer. And as time went by, we added elements to that team. In this case, there are technicians for mining dams, and then later engineers, even if they are generalists or from other disciplines, not dams or tailings, and at a second moment, engineers who are experts, specialists like geotechnical engineers, however, not yet in a position of leaders. And in the last moment, which is the present, I consider it to be a great evolution. Expert engineer, a specialist in leadership positions such as coordination, management, direction, EOR, and independent consultant boards. Now moving on to the practices. Over time, basic practices, and it's important to remember then. It used to be a very rudimentary one, which is monitoring. Here we have a reading manual plus the record of measurements in spreadsheets, then the text of a monitoring manual, as well as analysis, which is a systematic, a critical one. Then you see the automatic transmission of the readings, data management system and geotechnical monitoring systems, and now new digital technologies bringing this whole debate to the present, the use of those new digital technologies to process data, to optimize routines, to develop predictive models, etc. So always going back to the core of the debate, we saw aspects of legislation, standards and norms, and in some operational practices, bringing the past to the future in order to provoke the bringing of the future. And this is just a provocative photo. What is the future? What is the future that we call it future all the time? Isn't it the present already? Are we not practicing it already? Maybe we are. Maybe we are practicing methods and futuristic technologies in a practice which aims improvement. And in this topic, I also like to talk about a topic which is not often mentioned, but it's important, I believe, for us to refer to technology such as smart dams. This is not often mentioned, but now recently I've been in an event which is very relevant, ICODE event in China. And this term was often mentioned. A lot of papers were published about new technologies that can be used in dams. This term was widely used. And it consists of a new kind of infrastructure based on a physical integrated dam with new technologies that are cutting-edge technologies. In this slide, you see the cover of a book published in this event that says Smart Dams, Concepts and Practices. That's the title of the book. And in the book, you see a lot of progress that's being made, especially in China, about a few topics that we're going to talk about quickly. And in the technologies, among them, I point out the IoT, Internet of Things, big data, cloud computing, and AI, artificial intelligence, which is the base of the smart dams concept. In this case, AI. I'd like to point out the machine learning example. Also, providing as an example the publication of a paper that we did in this event with Electrobras colleagues about the determination of reference levels for instrumentation, in this case piezometers, for the Tucuruí hydropower plant. It's a very important dam, very important plant, using the machine learning technique, which generated very interesting results. The system is fed back and it learns from itself to update reference levels as the dam undergoes different situations. And this is just an example, but going back to the concept of smart dams, we then have a list of gains: acquisition and automatic transmission of monitoring data. In this case, that's IoT. Intelligent or smart archiving and management of monitoring data. They make up all the real-time monitoring, and so far we have well-known practices and they are widely used in our daily routine. This has been already mentioned in some of the lectures that were given here. Professor Schneid uses it widely, and we need to be careful with how this data is managed. It's a lot of data and needs to be managed in a smart way. That's where we use the smart dams concept. Self-diagnosis and predictive analysis based on machine learning. Now we're going into less known domains. These things are less talked about. They're new, as well as decision making and automatic action implementation. For example, remote triggering of equipment and automatic response to critical events. We are providing an approach within the smart dams concept, but these topics are based on the performance-based approach, which is totally related to safety management, which is the topic of this panel. And within this topic, the smart dams one, we finally go into one of the trendy, the trend words, the digital twins. Within this concept shown in this event in China, I'm using it as a reference. Smart dams is a concrete representation of digital twins in dams. In the case of this event, the tailings dams represent a model that preferably should be 3D. It's dynamic, live, as we said. It's performance-based, able to learn continuously using monitoring data that comes from the physical structure, and providing a complete description in real time of the dam performance. Note that the objectives are analogous to the performance-based analysis approach. It should be validated continuously, and then we reach some of the basic elements of risk management, which is the possibility to forecast events, to predict events, usually failures, early warning, modeling for drills and simulating scenarios, as well as contingency planning, automatic or not. Once again, the mention here to risk management and increase of safety. And to wrap it all up, this presentation, after this brief history and within the domain of the new technologies and the performance-based approach, I'd like to leave you with a proposal, which is not mine, it's the whole industry's. It's in line with the standards that I mentioned, the proposal of ideal monitoring model and risk management for the present, starting now, which is the performance-based approach, as well as risk-informed, associated to digital twins. We believe we're going to use them increasingly more. Thank you. Thank you, Marcus. Now it's your turn, Teresa. Good afternoon. Thank you for inviting me here today, for being in this event. We're going to go on with the panel with the topic monitoring of the tailings structures in a way to minimize risks. I come from a hydropower plant background, so please bear with me and make a parallel in your minds. You're going to need to transcribe and do some kind of simultaneous translation in your minds for mining, okay? But I really enjoyed this flowchart. It's from an Austrian that developed the Austrian dam safety plan. or Switzerland actually, and it begins with the pillar of structural safety. We work in design and construction in a way to minimize risks. This chart shows this. We begin investing in design and construction in a way that we minimize risk as much as possible so that we don't have managed risk later. These are the risks that we cannot zero down, like hydrological risks, that's a good example, and so forth. The remaining risk, so to speak, is the one that we're going to manage during operation. And to do that, we use the monitoring pillar as a support, which is predictive maintenance. Monitoring could indicate the need for maintenance or corrective maintenance in order to recompose structural safety. And if all of that goes wrong, we have a third pillar, which is the emergency response plan, which is what we need to be ready for, but we hope we're never going to need to use. But in order for the monitoring effectively works as a dam safety pillar, I'm sorry, I'm going to have to read from the slide. I apologize. My glasses don't allow me to read from the bench. Okay, I'm going to read from the slide, okay? It says the monitoring is only valid as an essential tool. Yeah, that's a good idea. Once again, apologies. I'm an old lady and I cannot read from there, so I'm going to read from the slide. So, instrumentation has no value in and of itself. There's no point having the best instrument if it's not working correctly, if it's in the wrong place. The data collected on their turn also do not have intrinsic value.
The instrumentations in dams can be effective in minimizing risks when we know where and how to instrument, how to obtain the readings with quality, and how the data will be analyzed. I'll speak briefly about each of these items, beginning with how and where to instrument. We don't instrument because it's in the law, because someone asked that they wanted to be the instrumentation. Because we believe this. This is a pillar for dam safety. I have here an example of hydroelectric dam, just to show how and where to instrument the instruments. So good, bad, are they right or wrong? It is an example of Irapé. It's a rock fill with clay set in the 205 meters high, and the failure modes are overtopping and stabilization. But there are two failure modes that different for you, which is internal erosion by concentrated flow and cracks in the contact of the dam with the abutment, and low stress in the bottom of the valley. Fernando Schneid left, I think. Fortunately, he wouldn't like this. Oh, you're there. Okay, of the neural stresses at the bottom of the valley. The project, following the logic of the three pillars of dam safety, the focus of the design and the construction, the minimization of the risks. The dam, the structure has to be safe from the beginning. The case of Irapé, a number of measures were done in the design and construction period. Rectification of the foundation in the deep valley to avoid effective null stressions with compaction using terrace gravel, which more clay gravel in this orange A in the lower part of the nucleus to reduce deformations. Place plastic material, this green line here, in the contact of the clay nucleus and the surface of the foundation to avoid cracks and in the traction in the contact. this fine material that they upstream, cohesive of the nucleus, to work as material to feel if any cracks appeared. You can see it's not written here, but there's a more robust filter here downstream. All the concern of designing and building well to minimize risks. These are just interesting photographs. Here, the first is the copper dam. We had to stop the river there, and the working with the CCR at the bottom, the valley, how closed it was, how narrow it was. The dam is 205 meters high, but only 5 meters crest. It's not very friendly for clay nucleus and the rock fill. Well, once you ensure the first pillar, we go to the second one. Now, how are we going to monitor this? That is very well built, focusing and minimizing the risks. For instabilization, there are wide monitoring of pore pressure and effective stresses. Stress strain studies showed several points in the dam with more reduced stress strain. This was a concern, a specific concern of this project. The monitoring of deformation, the manometers, piezometers with vibrating wires. Not all dams have this kind of instrumentation. This was specific to IRAPER in that a number of instruments. For internal erosion, which is a very interesting case to show, the core, when it deforms, we speak of hanging on the cracks or traction can appear on the contact with the abutment, and to monitor this failure mode, sets of total sales and piezometrics and piezometers to calculate the effective stress. I got just one to show you on the right abutment, so the piezometers with stress, total stress cells, and we can plot the pore pressure. Of course, it varies with the level of the reservoir, and this total stress, and we get the other question, internal erosion of the bottom of the valley, also showed by the finite elements model. There was the leveling, this marking with a CCR, or the compaction, and also the monitored through total stress cells. At the bottom, you see one a bit upstream, another one at the CCR, on top of the CCR, and downstream. With this, we came to the graph C of this effective. It's interesting, the gain of stress here throughout the construction with the rise of the fill and with the filling of the reservoir. As you have the saturation, obviously there is the stress, effective stress reduces, and then it's stable over time. So this resulted in the instrumentation of the dam. Well, where and how to instrument, it's a question of a choice, a surgical choice. It's not spreading instruments wildly to meet any norm or anything like that. Really, we had to think through what were the design intentions, what we want to know afterwards, after what we want to monitor, adequately monitor the facility, and deliver new technologies which we don't need to set them simple and robust instruments. It doesn't mean that if you have instruments, the most recent automated instruments, it doesn't always mean that you're safer. How to obtain quality readings, the instruments well installed, the readers knowing what they are reading for what, and how the data will be analyzed. Generally, a preliminary automatic data analysis to allow that as soon as information arrives, there's a triage You have to look that at that moment. You can wait for the moment of a more detailed analysis, and then the analysis by the detailed analysis of the data. If the facility is working as smart, if there is any change of conditions that can indicate any risk. I brought here some dams trying to make a parallel with you who now have the challenges of the stacks. Some high dams. I got rockfill dams with concrete faces. They are only rockfill. These are examples nowadays of which are the highest in the world. This is the Chaglia in Peru, 211 meters and only 270 meters on the crest. It wouldn't have a clay core in this shape. I highlighted this because the designer are Brazilian, and the designer and the builder are Brazilians. The cross-section is rockfill with a concrete face. It can deform very little. The concrete is on top of the rockfill, which is impermeable in this case. Campos Novos in Santa Catarina, Xingu, Yamagis, 233 meters high in China, 200 La Yesca in Mexico, 210 meters. The dams in Mexico, it's interesting because they managed the deformability, very high deformability rates compared to the Brazilian dams. And there are interesting cases in this dam. And the current highest in the world, which is Nurek in Tajikistan, 300 meters. One in China in construction will come to 312 or 315 meters high. The mining and water dams, rockfill, have similarities. Several concepts can be incorporated from one side and the other. There's this exchange as deformability modes, tensions and settlements expected, mathematical and measured values and models. For this, I was very happy with this invitation of IBRA. I think it's very interesting, this proximity between mining and the hydroelectrics dams. They're well ahead of dams, but the mining has moved so much forward. The hydroelectrics learn from mining as well. I think this is the discussion, this dialogue is very good and very important for all of us who work with these facilities. Thank you. Thank you, Teresa. I think the exchange of knowledge was just right. Thank you, Teresa. It worked just right. Well, the exchange of knowledge is always important when we get two sectors that have similitudes and can aggregate value together. It's always very important. Again, it's the focus of all of us here. Learn more and more, and that we will do safety and transmit this to society. That we're working in a responsible way. Now, speaking of the inputs, if you would like to send questions, comments in, please. Well, let's go. What are the best methodologies used for failure modes to determine the levels of control of the instruments? In your view, how can we have better performance in defining the levels of control associated to the failure modes? For mining, where you don't have the loading of water, it's harder for, say, for the hydroelectric plants. We can do the deterministic models, which is modeling the dam and putting the levels, expected levels of piezometers or deformation, what would indicate the dam is unsafe. But in the case of hydroelectric plants, where we have a big variation in the level of the reservoir, we can correlate statistically the measures, especially of piezometers with the levels of the reservoir, and have ranges of the expected, the water level such and such. I expect this pore pressure, for example. We have the range of values which are expected. It doesn't mean the dam is an alert or attention. It's just reading a different reading from what was expected for that level of the reservoir. For instabilization, it's relatively easy to be done. For internal erosion, it is harder, but it is not such a critical problem for you. You don't store as an Irape 200 water column behind the back of the dam of the facility. For you, it's not so critical. But that depends of the particle size that could be carried for you to see if the gradients can be met or not. We do correlations of the gradient and not directly of pressure. And it depends of the material to be carried, and if you have an undrained outlet, if you have an undrained the material, very sandy material, depending on the coefficient of the material, sometimes a gradient 0.15 is high on the outlet. So it's very specific for you to establish the control levels. Speaking more general terms, very difficult to give a very precise answer to this question. And let me just add to what Teresa says, taking advantage of the link that she put up in her presentation between deterministic and the statistical models methods. I believe there isn't a recipe. Each case has to be determined the most adequate methods. In general, you have a stage of preparation of designs, and you don't have historical data in the monitoring. Obviously, you can't do a statistical analysis because there's no history there. It is deterministic models in general, from what I know, through using modeling, whether, for example, with the stability analysis in the failure mode stability or other modeling in the case of other failure modes. In the case of hydroelectric plants as well, taking advantage with Teresa's presentation with the example of the publication that I mentioned of determining levels of control for the Tucuruí hydroelectric plants. Once you have a mass of data and it's possible to get correlations which are coherent with this history of data through statistical analysis, in this case, you can and you may, in general terms, use this tool and determine levels of control based on this history. In the case of Tucuruí, we used a method using machine learning, which is a case that goes beyond the statistical model, although it was also used, and a final observation on top of the statistical, because in the case of dynamic facilities, I'll use dynamic to refer to the dams that are being built over time and have tailings being disposed of there, which increases over time upstream in the facility. So all efforts, the displacements, number of questions are being changed in the structure over the time. I think it is more complex to do a statistical analysis based on historical record. What happened in the past, and the reality is different from what is happening today. So this is the highlight that I wanted to put up. I'd just like to add to that the control values in general, they can't model the values, and sometimes we use values from similar facilities, or you can make a correlation between instruments, a correlation with the size, which is cause size. You have to go case by case how you can treat this data. In the case of machine learning, I know here, since the mining people are quick to react to ideas that are presented, one thing a person has to be careful with, if you have, for example, piezometrics which are rising, you program for it to foresee the next reading, it will always foresee that one is greater than the previous one. This might not be good for control value, just adding that in when we use these tools. This is a very interesting point, how we use technology to aggregate value. What are the variables we should lock in to have a true simulation? With regard to the control levels, how do you see this? Which instruments have to have their levels of control defined? Only the critical sections or all installed on the facility? For hydroelectrics, we do all of them. But the ones that come from design, we call attention and alert, and the other we call reference values. When they're not associated to a factor of safety, we do it for all of them. I don't know if it's good or bad, but that's what we do. We do it for all of them. With terms of reference, only for the critical sector, or we use the piezometrics. It's easier to be done. For displacement, it's very difficult. I don't know about you, but for ours, all that we do with deformation, the models have given much less than what you measure in the field. It's harder for deformation to manage these values. And for piezometrics, it's nice, isn't it? It's an easy one to do. There are some which are challenging. A point that Teresa raised during our discussions was what to instrument. Sometimes we have anything that happens on the dam, let's put in an instrument, a further instrument. An instrument has to have a value. It has to generate a value, knowledge for the facility for it to be installed. It's not just a question of getting up, let's have another piezometer or another surface marker, but it has to be part of the instrumentation as a whole. Let me add in with this point. The subject levels of control. Since I began in engineering, all the events that we go to and the meetings that we have, it is polemical, it is controversial. A lot of people are against it, but I think it will depend on each case whether you're going to adopt this or not, and if you adopt it, whether you're going to adopt it for a dam, for all the sections or not. I believe that we have to be coherent with what you're going for. Monitoring is associated to the failure modes that which the dam is subject to. And in general, I believe that if you define to do instrumentation project for a dam in 5 sections, for example, and you decide also to define reference levels to assist the operators in the daily routine of monitoring, I think that coherence in this case, in general, of course, it is not a rule for all cases, but in general, it should be you should establish these levels of reference so that the operators can follow the routines for all the instruments on the dam. The critical section is the most critical. It's more associated to a greater risk. But then what would be the reference of the operator to the reading of instruments which are in other places? If they defined there has to be an instrument in a less critical position, theoretically, there's a failure mode to be assessed there, watched, as it were. That is what I would add. The problem is, in mining, how, since you suffered a lot with events that occurred, and the way that the regulations work, you have a fear of the control value because this information goes to so and so and so, and is it a non-compliance or whatever? In our case, it doesn't become anything. You just have a dam. So if it's a reference, it just means that that instrument is reading something different from what it always read or what it expected it to read. And we're going to analyze what is happening. I don't have to say this to the regulator, to anybody. It won't generate a non-compliance. So we accept this with greater ease, maybe. Now, when linked to a factor of safety which is deterministic, we give more attention, look at it carefully. Sometimes it's one instrument. It doesn't show any real problem. Our view of control value is this: you have 8,000 instruments. I had 8,800 instruments. I had a team of 4 people to analyze the instrumentation at the time. This was 10 years ago. Can I look at 8,800 instruments? So the readings were every 2 weeks, every 15 days. Impossible. But our system had the control values. Instead of looking at 8,800, we would look at 30. This was the objective. There has to be some care to not overvalue this question of control values. And this generates so many problems. The person is afraid of putting the control value, afraid of it being too tight because their alerts trigger non-compliance, non-conformity. So it gets away from the intention, the true objective. In this point, we're talking a lot. The performance of the facility during operation is very much evaluated because of instrumentation. How can we reduce the risks in the installation during the works? And how important is it, the first readings, to check this performance in the installing the instruments? This answer is so huge. I don't know. The team has to have a good technical specification. They have to be very well installed and working. The readings, I think, is very different. Your readings are very different. The facility grows and all this assessment is done. Our problem generally is when it is filled. The first filling of instantly the instruments react, and we have to react to this response. I don't know how to answer that. Let me add in, I think we have sought more and more, all the companies create the lines of defense. And obviously there's some company installs them, there's the designer or a company that is doing the technical monitoring to validate this installation. This is a point that would add a lot for the performance of the instruments in all the facility. Instrument is so important that you should have more people assessing this during the implementation and then throughout the works, especially when you're very close, is something that can add and improve the performance as a whole. So we have more time speaking on the instrumentation and the levels of control. When we look at instrumentation, your view, does this data, how should they be dealt with? It's important they should be restricted to people who are going to do the assessment, do the performance of the facility as a whole, or more people, even inside the company or out of the company, should have access to this information. That is maybe the most controversial, but I wouldn't answer in such a way that whether you should or shouldn't share or integrate the information, a mass of data in an outside environment. This has to be assessed. There's a discussion rolling about that in Resolution 95 as well. What I would say is, picking up on the previous panel, it was said in the context of JSTM, one of the pillars of the new inputs is transparency with all the stakeholders, whether it is a regulating agency or other stakeholders. I just think there should be care, special care should be given with the way this is done, because within a company, a corporation, a company to organize and within which you establish adequate governance for structure, another pillar of our standards, you think favorable for structure to look at certain data, what should be alarming or not. The outside environment, receiving the data, do they have this governance capacity Do they have the team to look at it and do the analysis? This is something that needs to be. There's not just one answer for that. It's important to transparency, important there should be governance as a robust facility which allows you to have analyzing the data in a careful way. Quite honestly, I don't think it increased the safety of the dam, make available the instrumentation data for outside people, for another agency, or the instrumentation analysis involves knowing profoundly the facility. Or the most you can do, you increased or reduced or dropped. It's not something without value, really. It's the Corps of Engineers says the data themselves have no value. They gain value when we give meaning to the data. I don't think this adds anything, any value, or makes the dam safer, or increases the resilience of the dams. I think each company has to have the management of the information, analyzing the data in depth, knowing at depth what are the projects to be able to speak and say if that's good, bad, and the values. Attention alert, the signs to guide you in the middle of world of massive numbers. Automatic data acquisition becomes bigger still. Where are you going to focus? This is the objective. That's my opinion.
Thank you, Teresa. Well, folks, I just want to say thanks to everybody for your attendance, your questions. This is the end of the panel. I just wanted to hand the floor over to the panelists for their final words. Well, thank you once again. Thank you all for your input, as well as for the invitation. It was a pleasure to be part of such an important event. Thank you as well, and I apologize to be an intruder here in your area. I hope I gave you valuable insights.
Obrigada.
Thank you, Teresa. Thank you, Marcos Antonio, and Marcos de Avila. Let's take a picture, group photo, if you will, please.
Muito obrigada. Dando continuidade.
Thank you very much. And now, moving on, we will begin the 7th panel with the topic From the Plant to Final Disposal, the effects of ore properties and operational parameters in the dewatering, filtration, and tailings disposal. This panel will be moderated by the Senior Process Engineer at Usiminas, Pamela Karen Costa. And I invite to the stage the panelists Ana Risoli, Master Geotechnical Engineer at Vale, and Wanderson Silverio Silva is a Samarco Specialist Engineer. And the floor is yours. Good afternoon, everyone. First, I'd like to thank Ibran for organizing the event and also for inviting me to be here to be a part of this important panel, very important to the mining industry. Thank you, Aline, especially for the invitation. Thank you all for your attendance. And I salute my colleagues here in the panel, Anna from Vale and Wanderson from Samarco. They are professionals with a lot of experience, a lot of expertise, and they will bring a lot of value to our panel. Our panel will approach the challenges of all the tailings generation cycle. We're going to approach physical, chemical, mineralogical aspects of the ore, and operational challenges when it comes to dewatering, filtrating, and disposing of tailings. I hope we all enjoyed this panel. Anna, the floor is yours. Good afternoon, folks. It's a pleasure to be here with you, especially in this panel where we have a very heterogeneous group. We have people from process, geotech, and with such different operations. Samarco has more sandy tailings, Valley halfway there, and we'd like to see an overview of what are the different problems and how we can help each other out. Now, from the plant to final disposal. Just to give you some context, Vale's journey is a long one since 2012. We have the first designs for filtration plants. They were the pilot designs. We began doing them in 2015, and after that, we began in 2018 disposing dredged tailings in PDR Cianira, our first operation of stacks with dewatered tailings. In 2019, we resumed the decision of implementing filtration projects, especially in Tabira Brucutu. After that, we began our trial embankments. We had a trial embankment in Itabira 2020, Brucutu 21. In 22, it was an important year for us where we started up our large plants and large structures such as PDR CMD in Brucutu and PDR Burachudo. We're going to elaborate on that during this panel. After that, there was the trial embankment in Agua Limpa with a much sandier tailings closer to San Marcos, and in 24, the startup of other structures. Now, 25 onwards, we've been working increasingly more with new structures, and we want to get to a point where operations are more efficient, safer, especially by processing the moisture content. We are working with a material that underwent filtration, but we are also working in an environment with high rainfall levels. So we need to find a compromise to manage to maintain low saturation, low moisture content, even during the rainy season. And to give you context, why do we want to talk about generation to disposal, the whole journey? In the first moment, the tailings is generated in the concentration plant. We filter the tailings. It is sent to a kidney pile. It is hauled and it's loaded and hauled to another pile. We have different areas for process, areas for geotech, which don't always dialogue naturally, but there's a need to do so. Here we have all the tailings that used to be disposed on the dam. It is almost a construction material for this stack. It's a change of mindset after we began dry stacking. So we need to have much better control of what we're generating. That's why we're working closely with process. And I'm going to try and brush on a few topics. We could elaborate on that, but I chose to talk about the relationship between process and filtered tailings disposal. We tested out different tailings. Wanderson's going to talk more about that, about the possible mixture ratios of tailings, but I'm going to focus on specific operations. Our case study is the PDR Ipoema Burachudo, a pile or stack located in Itabira, one of the largest operations we have today. You see all the area in brown is actually tailings. It shares area with waste. and this is one of our largest operations in Vale. Just to give you an idea of this tailings, which is compacted, it comes from the Conceição plant. It goes to separation process with cyclone. This generates coarse and fine tailings. We call sandy or slime, ultrafine. This material, the fine material, is thickened and they are put together once again to be filtered together. We like to say that we are filtering the total tailings. All of the particle sizes generated in the Conceição mine is sent to Ipoema Borachudo, stacked and compacted. To give you an idea, here's an overview, a bird's eye view. We have the thickener, 3 buildings for filters, and the kidney pile where we have loading for final disposal on the stack. As we said here, even though we filter all the tailings, it undergoes a separation process initially. We have sandy tailings being generated and ultrafine tailing. And I wanted to show you this image just to give you an idea of the difference among those tailings. And you can tell that visually the size of the particles were enlarged 250 times. In ultrafine tailings, you can see that it's a lot smaller than sandy tailings. And this gives each tailings specific characteristics, which is a challenge for us in operation. For this specific operation, we chose to stack total tailings. It's a mix of coarse and ultrafine tailings. Here I have a range which is more or less 70 to 90% of total tailings and 10 to 30 of ultrafine. And that's about 17% of ultrafine in the more actual. This was something that was imposed to us in order to spare the dams that we had available in the complex. In other operations, we chose to stack sandy tailings, which is not easier tailings, but it can be dewatered easier, in an easier manner. And to send ultrafine tailings to an existing structure. But in this case, for this operation, we chose to spare an existing structure, specifically to reuse the water in this structure and stack total tailings, completely all the tailings generated in the operation. When we began to filter that these tailings, we saw the particle size distribution was varying a lot. If you see the particle size curve in blue, that's what we call known tailings. We had already performed the characterization, built a trial embankment, we had tests. That's what we were comfortable with working. And every 3 hours we would use to sample that tailings in the operation. And during the sampling, we noticed a big variation, a lot more than what we expected. In this case are the yellowish lines. We noticed that on average, the daily average, the tailings would remain within the blue curves, but if we were to look under a microscope, if we were to enlarge every 3 hours, you saw more variation. And this generated significant particle size variation, generating variation of optimal moisture content for compaction. One thing is related to the other. And the post-filtration moisture, which was also being impacted. If you have finer content one time and coarser another time, the filter is going to perform differently. And this generates operational difficulties in disposal. The more accurate your particle size distribution, the better the compaction flow. It's going to be better, more accurate, because you have the same output and the same optimal moisture. You follow a recipe, a cookbook recipe. We then started investigating what was happening. We then talked to the process team. We noticed this change, And we wanted to understand it. To do this study, we used a screen with the undersize of 45 microns, 0.045 microns, and we checked how they were how they were exiting after filtration. We saw within the filtration process that we don't change the characteristics of the tailing, you only dewater it. So what goes in is the same that what comes out, but we saw that there was a bigger variation of particle size after filtration. And why is that? Because some processes that occur in filtration, they are done in batches. For example, the thickener needs to reach a certain density so that it begins to work and then disposes tailings towards filtration. We started noticing that some processes in filtration were generating that variation. The stability of variation generated the need for interrupting the filtration process, and within the interruption, this would increase the instability of the process. Within it, we had particle size and moisture content. And to solve that, the options were disposing using the chevron method in the kidney pile. The chevron method generates more homogeneity of the particle size. At every 3 hours there will be variation, but as a whole it's going to be more homogeneous. Implementation of an ultrafine tank, you can then ensure that within the functioning of the thickener, if you have an ultrafine tank, it's always going to have a minimal mass for filtration. You then ensure that the cookbook of the 80-20 that we were working with, 80% sandy and 20% ultrafines, you're always going to have a good mixture and generate a proper particle size, a more constant one too. As well as other process stabilization tools, we were ramping up a filtration plant, so other tools were also used for control and to improve the process. With that, this graph shows clearly what gain we saw in geotech by connecting with process in order to generate more stable tailings in terms of particle size, but also in optimal moisture content. After all these measures were taken, we managed to generate stability in moisture content with a gain that we had stable moisture content below the filtration design moisture. It was sized for 15 moisture content, 15%, and today we can deliver about 12-13%. It's not exactly the exact compaction rate, compaction moisture content, but it involves less operational expenditure on the pile. We can reach the correct compaction rate with that. At the end of the day, all of this talk with the process team generated a lot of gains for them and to us. We no longer needed to interrupt work with the pile. That meant less shutdowns in the plants, and it was a win-win situation at the end of the day. Besides that, within our operational cycle, we still need a few tools for when the material is outside of the moisture content that we need to compact. For that, in Itabira case, we generated an area called yard for moisture content reduction. It's an area where I sand the tailings if moisture content is too high. Of course, this is not a solution which is operationally favorable. You're going to have to, dump it first and then move it and then do things all over again. But then in other operations, this isn't possible. But we get more leeway for us to deal with the problems we might find in our operations. Going back a little bit to geotech, this dialogue among process and geotech was so healthy we managed to follow the approval criteria flow in a much more strict manner, much more fluid too. There is a first particle size approval in the beginning of the process, and then moisture content approval, and the moisture content approval gives you an idea of where the material is going to send, if it's going to be sent to the stack or to a layaway area. If I have wet spots or water buildup, I need to do something to improve the characteristics of the material. And then an approval of compaction, which is going to generate the parameters we want to reach the design parameters. Today, the approval of the layers is made using the dry density method initially. Then we calculate void ratio and then saturation. Yesterday, a lot was said about how these stacks can at some point get saturated, but at least here, usually, you want to be further away from 100% saturation. This also became a criteria then for approval. With that, I brought this from the beginning. This is a chart showing the ramp up. It was monitored weekly for this plant. We can see seasonality clearly, dry and wet seasons. We see the growth that happened after the learning curve. And with that, we got lucky this week. Monday, we wrapped up June with a compaction record for Itabira tailings. A tailings with a part of ultrafines, with a parcel of ultrafines, and it's harder to filter because of this part of ultrafines. But after operational adjustments and learned lessons, we hit our record. So there was celebration this week. We compacted over 1.2 million ton. And we need to remember, it's not generation, it's compaction. We generated, filtered, and compacted and approved all of those tailings along the month of June. That is all. Thank you. Good afternoon, everyone. First, I'd like to say thanks to Aline and Ibram for the invitation to be here once again with you. This is such a great event. I just want to talk about some of Samarco's experience in disposing of tailings. Here's a brief introduction. Samarco is a joint venture between Vale and BHP with a capacity of 30 million tons of pellets per year. It produces in Germano, that's where the processing plant is, but by means of a slurry pipeline, it is sent to Ubu in Espírito Santo, where we have a port, and then it is distributed to the market. We had the Fundão dam break event in November 5th, 2015. We deeply regret this event. We never forget it. We were working towards full reparation, and in a certain way, it shapes how we are operating today. This operational resumption in Samarco, we decided as strategy to no longer use dams. This is a strategy that is still adopted. In this process flow chart, you can see that we have our tailings as well as Anna showed in Valley, ultrafine tailings called slime. These are about 20% of total tailings, and the flotation tailings, which is sandier or sandy silty, that's 80% of the mass. Today the tailings is filtered. We have filter discs using vacuum, and then we dispose it on a stack, PDR Alegria Sul, where you have tailings disposal and waste separately. A detail here is that we have a perimeter channel with compaction to help us in terms of erosion, drainage, and vegetation. We have here a summary of our controls, which is usually done in this tailings disposal. Highlighting void ratio and permeability values for the tailings from flotation. We only stack flotation tailings, so the permeability values is 10 to the minus 4, 10 to the minus 5 per second. These are values that allow us for a good permeability of the stacking. The particle size curves, even though they're average ones, usually you see a variation. A very large one in particle size. But here we can already see the relationship between disposal and mineralogy with the process at a certain point in time. We had a particle size distribution which didn't change that much, but with the curves on the top, closer to the left, you can see how our actual specific mass of these particles was varying, the proctor and the earth fill density. The combination of those variations began arriving at a void ratio that is out of specs. We need to study this material. We need to address this as off-spec until you understand if it's fulfilled with the design criteria or not. And then with the more or less homogeneous particle size, we needed to start studying the mineralogy of the material. And we saw that there was an increase of the iron or the iron grade. Mineralogy impacted on the density of the earth fill, or the maximum density reached with compactions, with the packaging of the materials when compacted. Hematite is speculative. It was identified, the increase of the perceptual was because of the shape of the particles. And facing this situation with another extensive database that we have, we just published a master's degree thesis with my colleague, where they use machine learning and statistics to evaluate the influence of mineralogy and the chemistry of tailings on compaction parameters. It's a dissertation, a thesis defended on UFOP. We are working with sandy tailings, filtered and disposed, but we have a future ahead of us where we need to work with filtration and disposal of tailings with low grade of fines. This will allow us to continue operating without disposing tailings. We did trial embankments using different mix ratios. For mix ratios with low fines ratio, we used the current plant. We implemented controls and a blending tank, as Anna showed us, in order to run tests. On the bottom you can see the control for the dosage. It's a small variation. We will never be able to attain exact values, but that's the control that was applied during this filtration. This table shows the different ratios. The first figure is the ratio with sandy and fine tailings, and the second, the fine material. As we add fines to the process, we can see that there is a reduction of the filtration rate of the filtration tuff. Figures range from 2 for 95.5 tailings. Sandy tailings today have a tuff of 2.3 to 2.5, reaching a value of 1.1 to 9 for 90-10 ratio tailings. And on these tests, we identified what was the limit for operation of the filtration plant, the filters, and the capacity for filtering. When we reached 85-15, we see that with a very quick drop of the cake expansion, the cake thickness, which indicates a clogging of the filtration fabric. And under a microscope, we can see specularite, quartz, and some minerals which are clogging the filtration mesh. Mineralogy and the fines proportion then are impacting the filtration process. So for ratios above 15%, we needed to use the press filter at a semi-industrial scale, and we performed tests with 80-20, 60-40, and pure slime. And the productivity of the filter press is better as the proportion of fines is increased, according to the concept of the filter itself. All this material was tested in trial embankments at a large scale with the idea of simulating operational conditions and to check beyond the compaction parameters how workable and how appropriate the material was. Here are some results. In terms of particle size curve, we see this gray curve, that's sandy tailings, just to give you a reference. In magenta, it's 95.5, 94.6. Green is 90.10. Red is 80.20. And brown, 60.40. These tests are filtration tests at about 10 to 24 hours. What we can see here is that during a short time frame, we have a range of particle size curves, and we can see the variability of process when it comes to generating those particle size curves.
Another thing to observe, both the sandy tailings 94, 9010, they have an overlap. When you begin to get closer to the finer material, there's the overlapping of the curves. It means that even maintaining a fixed portion of fines, you have a variation that can go from a theoretical concept of 94.6 to 90.10, for example. These shows the curves of the mud, the slurry, and this obviously has an effect on the compaction curves. The interesting here is that as you add fines, we have a reduction, optimum moisture, and the influence there is with the software. This tendency inverts when you get to tailings 60-40. The black arrows indicate the distance between the moisture leaving the filter and the average of a range. We call it a target range, which we understand is the ideal compaction curve. For it to be clearer, I think this graph is better. We have the distance, showing the distance of the geotechnical, the exit of the filter, and optimum, the average of them optimum. Today, the sandy the filtering delivers a bit below the optimal moisture. It has the capacity, but the tailings during transportation, for disposal, it loses about 3% moisture. We have to add, Bruno commented this earlier, you have to put water for compaction. 94.6 and 96.5, it has a moisture very close to optimal. And as we raise, we have 90-10, 2%, 80-20, and mud at values above 5%. Also, as you add fines, the effort you have to make to get to the ideal compaction point is much greater. The workability is worse. The trafficability, we begin to have problems, in fact, when we get to 80-20 and above. Well, here we have on the left densification values, void ratio, average values on the right. When you work on the moisture part of compaction curves, we have a loss of, I think, about 5%, taking to void indices very different, the degree of saturation that can be undesirable for disposition, rather. Well, here is a slide that from BVP. In operational process, what's important for us? It's important for us to have foreseeability, predictability, but the outputs which are correlate to this variability and the filtering paste, we can consider the grains, the particle size, the moisture range that I'm working on, that I need, that is being filtered. And if this varies over time, it's important to have this foreseeability. We want to have operational efficiency. That is, sometimes it's in this efficiency you have to have an adequate control system. It was said today, not always HILFA is the best way of controlling this. Today we have some projects have considered adequate ranges of compaction controls through void index ratio and the degree of saturation. Finally, we need to be flexible. That is, if you have these units coming, the compaction and the rainy season, in some cases in the PRU, and depending on the project, we can be available. This moisture, the control during the rainy season, for example. What we have a deposit with the lithotypes, mineralogy, in both momentarily, and we do the extraction. Classification, processes of concentration, etc. There you have to choose the kind of filter. Coagulants and flocculants should be applied. For this to be effective, you need controls of density, the feeding these filters. This will change grain particle size, whether the curves of processes, the mixtures, as we said. This has to be tested to get the operational planners for the trafficability. And then the results for design a project that can, the best project. The structuring process confined is sufficient materials. When it's off spec, as was mentioned in the morning, what is our contingency? With the structure, this concept, the cycle that we followed, and I think we good to observe during the development of these projects. Well, that's it. Thank you. Samarco, BVP, the contribution in the presentation. Thank you for the invitation. Thank you, Anna, for sharing with us the studies and the progress that you are working on in your companies. Now we open for debate the questions from the audience. I would like to begin with a question. Anna commented in her presentation about the integration of areas. We know that the challenges of stacking cover different areas, but this became very critical and urgent among the areas process, as you said, and geotech. And so I would like to know from you, in your view, how has this worked? this integration between the areas in your companies and the sector as a whole, what progress we have had in the integration, and what do we have to improve further? Well, this integration is built. We found it difficult at the beginning to use the, find the vocabulary. The process team talks, the Minera geotechnic has in his mind the geotechnical moisture corrected by the dry mass. They work with moist. Even in this beginning, the vocabulary was very difficult. And also the question of necessity, coming from an operation where everybody is used to with dams, where tailings, although it has an important role, it has a role a bit less within a facility like a stack. We say we're building and operating every day. The dam, you have moments of construction, some moments of operation. So this is something that has been built. Today we see that this already is well advanced. They ask, is this tailings? We can filter it, but can you stack it? We can see the perception that 2 or 3% more of ultrafines, the operation of compaction, can be affected. It's something that was built very slowly. Today, we see this in a fluid way since we managed to discuss with them. For example, when I began the project, I didn't know how the hydrocyclone as thickener worked, and then we had to be able to speak the same language as them and understand what happened inside the mill that could impact the geotech on the other side. In the case of San Marco, it was a bit like that too. Since we had a processor which was without operation, the construction of the plans and methodologies of tailings disposal went through tests of filtering, tests of experimental fields, and the team which does the operations today and worked in this construction. Also, after the project was ready, you have to implement the project with GSTM. We have the training, there's an important phase, and San Marco has an interesting program, the knowledge management, which collaborates a lot because it's a program where you seek to record the knowledge which is specific to the company and leave it recorded for the training of new teams. It's a way of retaining knowledge. This program interacts between the various areas of the mine, the geology, the geotech, and then you manage to disseminate more the concepts of tailings disposal with the necessary controls and the needs. Now, with the tests of filtering of tailings, it was also a structure was built where we do in the operation. Today, we have specifications of filtering and moisture ranges that we need for disposal. So this is a contract with the beneficiation with the mill itself. We have, obviously, the objective is always, first of all mining, is to produce the ore. It's important to have contingencies that people see. Sooner or later, you have a mechanical failure, and it's necessary that the team is aware of what they should do when you get away from the specification. Just to give you an idea, we have a particle size control every 2 hours, which was unthinkable until a few years ago. A lot of training as well. Thank you very much, Vanderson. I thought it was very interesting that you commented on the program of San Marco of knowledge. Could you briefly explain what it is? Because Other companies might repeat this best practice of Samarco. Samarco chose some critical knowledge areas where you have concentrated knowledge. It's concentrated in a few people. The idea is have knowledge that was not recorded in, not formally recorded. The idea is to get the knowledge, generate formalization, store in a technical lab, and then disseminate the knowledge, getting it to be distributed more democratic, as it were, so people can have access to it. Interesting that within this program, for example, discussions with the geometallurgy people, for example, they saw that the analysis they do to close our mine, the analysis of what is the grade to have the product, this analysis to be extended by the tailings. So today they have a survey, what they are studying, the great database that we have, and with mineralogical and chemical characterizations, they want to understand that each closure, what's the distribution of the minerals, what is a product, what percentage, and what goes to tailings, the management that we are treating. Thank you. Let's go to a few questions from the audience. One for Anna. The question is, could you say which operational controls are done in the moisture reduction yards before they are put onto the stacks? These yards where you dry the material, it's a sort of just a dump area. We have sectors in this stage, and so to have the record, the yard in bay such and such we received between the days 3 and 4 of January, moisture such and such. At the beginning of the operation of the yards, we didn't have this record. So after the material went to the yard, you lost the traceability of the material. Once we saw we were losing information, we began to use sectors. So material with greater moisture, they go to the bottom of the yard, and then it takes longer to pick them up again. Material which has a moisture closer to optimal, closer to the near the front of the yard. With this kind of the record that we have the lab teams who, it's not systematic, but they, according to the need, they are called on to remove samples, take samples and check if it's adequate to take to the stack. But today, with the database that we have, we know approximately for tailings, for example, that is 15% moisture, it will lose about 1% a day, and so then from 3-4 days, it is ready to be taken up again. We have this sensitivity, this is more recorded, to be able to do the management of the yard in an intelligent way. Before, it wasn't done in such an organized way. Very often, the yard received material in the rainy season, and it was only taken up again in the dry period. Today, we can, even in the rainy season, take up the material so that the capacity is not infinite. The idea is that we should manage to store more, but it has a capacity, a fixed capacity. We have the rule beginning the rainy season with it completely clear. We need to use all the storage before the rainy season starts. During the rainy seasons, there are guidelines for storage and the pickup according to the operational criteria that we saw over time. Thank you, Anna. It was good that you commented the rainy season because we have 2 questions with regard to this. Could you comment a bit more about the impact on the period with regard to tailings disposal, and explain more about the specific operation planned in the rainy season, please. With a sandy tailings operation, the impact of the rainy season in disposal itself is nothing, zero. We began to operate this stack in December 2020. That it was an operation, a new operation for São Marco, innovative. The first time that they were stacking, there was a concern, a great concern with the rainy season, but the tailings has permeability and a particle size that the rain, in fact, it makes it even to do the operation because you need less water to correct it, and the workability is much greater. Looking at the particulates as well, which in the end we have control over. In the experimental field, in the test that we did, as I said, as you add fines, you begin to have a difference between the moisture and the filtering, the moisture that's adequate when you need for compaction. And when this begins to increase, you increase also the difficulty and the workability and of this material. We begin to operate a new stack in October. This tailing is 6% fines added. Difference in terms of behavior between the rainfall or the rains that occurred during the fill and the sandy tailings today, but we don't have the experience operating in the rainy season with this mix, so it's a period that we have to be more alert with contingencies prepared for the situation. That's our experience today. I think we have a very different experience. We have operation of PDE Cianito, which is very similar to the operation of São Marco. The tailings, ultrafine, directed to the Maravilhas Dam today. We don't stop the operation during the rainy season. There isn't an operational loss, which is significant. In fact, we win with the water that comes that we would have to add what moisture to. For the operations on the other side, in the southeast, which is Itamira, Brucutu, we have worked 20% moisture of ultrafines. And we see a seasonality of compaction, which is very significant. We have some criteria for preparation. We've improved our contracts for weather forecast when we have a forecast of rain night or that there's has a number of hours. We prepare, we seal with the vibrating roll, with the vibrator just to seal it, and the material, although it has fines in it, has an interesting characteristic. It doesn't permeate, so the surface flow is adequate without revealing with the rain. It's important if the surface drainage is adequate. Once the rain stops, we bring it back. If the preparation for the rain is adequate, we have an immediate return to operations. Very rarely do we have a stoppage that we need to remove layers. It has happened occasionally, but it is very sporadic. And of course, it is an escape valve for us. So we begin, once the rainy season, they clean it out initially. In other operations, we don't have this possibility. In Brucutu, sometimes we have another facility, dam facility, that in the rainy season we put a bit more fines into the dam and reduce during the tailings stack. But in each environment, which you have available? What are the pieces that you need? We do a plan which is a little different. Nowadays, tailings generation, we try to change it according to the season. We prefer to do the stoppages of the mill in the rainy season, and we do the plan for the year thinking of the filtered tailings to reduce impacts. We have another question asking to comment about the process of progressive closures of the stacks and the inclination of the slopes to allow the compaction of the coverage soil. Well, you saw the photograph that I showed. We have done doing this closure of the stack as we operate. This helps a lot with a reduction on generating fines, and we always have vegetation and the drainage following the disposal. This stack has the outside slopes 2-to-1, and the waste compacted soil with tailings. On the edge, you do the face, you do an additional cut with equipment to get to the final geometry. This is the process that we have been using. It's very important, this progressive closure, because the control of generation of sediment, it becomes much more efficient, and the drainage also, the preparing for the rainy season, the upper elevations, it is part of the preparation for the rainy season as well, this control during the rainy season. In Valley, we have different stacks in operation. Many of them work with shared tailings and waste. There's a waste area, an area of tailings, and very often we use the waste that we know better, which we know in greater depth, and we use the waste on the face, and of course, not just on tailing stacks, but also waste stacks. We do the gradual closure, very much with the impacts that Vanderson commented, the generating sediment facilities. Sediment containment facilities are mostly dams, where more and more we have the reduction of height, licensing, and so on. We use the existing facilities. The more we can avoid the sediment being generated in operation, it's an advantage, even to avoid maintenance, the retaking of the materials in the dam. Another problem is that very significant is generating particulates. We have a bit less when we add the ultrafines into the mix. This is a positive point, or the sandy, but also we protecting these slopes, we have a significant reduction for the environmental controls. Good, thank you. Question for Anna. With regard to internal drainage, if you could give a quick overview of the components. All the facilities have internal drainage systems. The internal drainage is designed much more for the flow, the base flow, than for absorption of the material of the water that will seep inside the stack. But there is this operation. We have done some designs, some simulations in the long term to understand the functioning of the drains. 10, 20 years, if the water will in fact seep and find these drains, the rainwater will get in. The flow already has functioning. The water flowing through the material has very clear. When we have used the sandy tailings, we see the characteristics of the flow much greater than the infiltration. So even within the simulations over many years, the biggest I've seen is 20 years, we don't see a significant infiltration that the drains feel this water getting to them. It's different in stacks where we work with sandy tailings, which is from Cyanita. The drain picks up the very water that is used for moisturizing the drainage, comes out the internal drain. This can be done. This can be seen. More water is used directly. It comes out of the drain. When I did a visit to San Marco, people would say the same. You see clearly the water coming out of the moisture in the exit. Just adding here. Let me add here. Each project, there's a different concept. It depends a lot of the project itself. Our experience, Paulo is the designer there. In the case of Brasileiro, I believe the downstream, the bottom drain, but this, we filled the valleys with compacted waste, and a big platform was built to generate the area necessary for disposal in San Marco. And the sandy tailings the drainage system was done in a herringbone layout, and it was believed that the flow would be low, it would be big or inexistent, and it has worked since the beginning of implementation. We have a great optimal moisture between 14 and 15%. We have done moisture. There is residual moisture between 8 and 10%. There's a significant input of the water used for compaction, beside the high rainfall that are typical in the region. Thank you, folks. Well, unfortunately, we got to the end of the panel. We have other questions which unfortunately we can't answer. I, myself, wanted to ask about the mineralogy impacts, but we can talk at the end during the break. I'd like to thank you once again, Anne van der Son, for your inputs. And I'd like to thank you once again, Ibra, for the invitation. Thank you for your attention. Thank you very much. Let's take a picture. Thank you. We go for a brief break. Come back at 4:15, please.
Só um pedido. Os palestrantes do próximo painel, eu peço que já dirija.
Speakers for the next lecture come to the VIP room, please.
Vamos retornando, retomando os nossos assentos, para que a gente possa recomeçar. Só um pedido, se alguém ainda tiver com fone de tradução, por gentileza, só entregar no foyer, por favor. Nós vamos agora para o nosso último painel do dia.
Now we're going to go on to our last panel of the day, which will be the last one in the technical program of Tailings Brazil 2025, the 8th panel, about the topic, a revision of ABNT NBR 13028, the construction about the text of the tailings stack. I'd like to invite to this stage as a moderator, Júlio César Neri Ferreira, is the Director of Mineral Affairs at IBRAM. Our panelists will be the Vice President of the Brazilian Association of Soil Mechanics and Geotechnical Engineer in the Minas Gerais state, as well as the Tech 3 Managing Director, Fernando Portugal Maia Saliba, as well as Márcio Fernando Mansur Gomes in the Geotech Committee and Civil Infrastructure. Thank you. I now hand the floor to Júlio to conduct the panel. Thank you, and first of all, good afternoon, everybody, to the survivors of this marathon, this two-day marathon. The comment I'd like to make about these technical norms, as you saw earlier this morning, they are there since 1993. It's a very old process, and since then they've run under Misael de Souza, someone that I admire profoundly. He is deceased for a while now, but he left his mark on the mining industry. And he was a pioneer. He brought to IBRAM the Norms Committee, which addresses the iron ore, copper, nickel norms. And he also designed these norms for the criteria of stacks and dams construction, 13028 and 9. Since then, we have revised those norms periodically. I think in 2014, I was in IBRAM as a coordinator of the Norms Committee. I was there for a while, and then I began a revision that was finished in 2017. I was also a part, a little bit, of the process of the previous revision in 2010 as a technician during the meetings. It's a process that we are well familiar with, and it is very important because it's a self-regulation. Today, for dams, we have a legislation which made good progress, especially Resolution 95, which put us at the same level as the best legislations around the world on dams. But doing what the law says, it's our obligation. We have no other option. That's our jobs. And the technical norms, as well as other standards such as GISTM, that we also recommend the adoption of, and they both dialogue, GITM, from the Mining Association of Canada. Over 60% of them have the MAC standards. That's what we call self-regulating. The industry must go the extra mile. This is extremely important for our reputation, showing that we are willing and able to go beyond what the law requires, and the law requires a lot. It's not an easy legislation to deal with. The costs to fulfill it are high, but it needs to be that way because, as Vanderson said, we cannot forget the disasters that happened, and we need to do our best as technicians that these things don't happen again. That's our jobs, and that's why these norms are so important. The norms for building stacks, dams, and the revision that Saliba will talk to us about, including a chapter about tailings stacks. This is the first of its kind here in Brazil. We want to start ahead of the game so that technicians have access to feasible text that is also technically justified, so that the safety condition is good enough to avoid any more disasters, complying with the GISTM recommendation of zero harm to human life and the environment. That's what we need to focus on. This chapter about the tailings stacks are really important to us. So I'm going to hand it over to Fernando and then Marcio. Let's begin with Fernando Saliba. He was responsible for the coordination. These norms have been under INBRAN since '93. We have the ABNT that looks after these norms, CE 2220. And we invited ABMS. It was a really nice invitation performed by Saliba with such a competent work, and we really thank him for this work. Saliba, the floor is yours. Thank you, Julio. Thank you for the invitation, and congratulations on the event. This is the last panel. We talked a lot about the operations with the tailing stack, and I think this is a good idea, a good presentation to wrap it up, to talk about the norms. Me and Mansour, we prepared a small presentation just to introduce the topic in very general lines about what kind of work has been performed by the Special Work Commission, which addresses the revision of the norms, a commission that, as Julio said, is conducted by IBRAN. IBRAN represents the mining industry, the mining sector. And he invited us as ABMS representative in Minas Gerais to represent it. I'd like then to begin providing a general clarification about the objective of the norm. What is a norm to begin with? The norm establishes those technical standards to ensure performance, safety. During the CEE Commission, I saw a lot of debate. People would mistake one thing with another. Norms are law, but they aren't. People would think that they're laws, but they're not. On the other hand, when the norm is mentioned in a law or a resolution, as is the case of resolution number 95, it becomes mandatory. It's important for us to clarify this, because during the meetings, sometimes these things were mistaken. Regardless of being mandatory or not, whenever we follow a norm in our design, we end up ensuring more credibility when audits are performed or for permitting processes, perhaps for investors, because norms, they standardize, and one of their pillars is consensus, meaning that decisions are not made by votes, but by consensus. A general overview, Julio brushed on it a little bit about the coordination. Ibrahim invited us to conduct this process and is supporting us very strongly. Hebron has an amazing team with a lot of experience in the process. We held 25 monthly and hybrid meetings, a very good attendance rate. It is free, nobody has to pay for it. If you want to be a part of it, you can. It's volunteer. The interesting thing is that we managed to group people from every different sector, from the mining industry or the regulators, even lawyers were part of it, professors. This provides with a very interesting environment for debate. Everybody has their own point of view. We then revised norm 13029, which is on waste dumps. This has been published November 24. We revised the text about tailings dams at 13028, which was also published in November 24. And we began the process for including within 13028, which addressed only tailings dams, and now we want to add a text about tailings stacks. The name of the 13028 norm, which was dam designs, now is called tailings disposal structures, which encompasses both tailings dams as well as stacks or any kind of disposal. This is really good, and Brazil is first in this race. This text about the tailings stack has already been finished. It has been discussed. It happened between December 24 to June 25. We have wrapped up the process of discussing the text, and it's now being sent to ABNT for a national consultancy process. So in the next months, if you're enrolled, you're going to receive an invitation. Anybody can be a part of it, and you can comment or give any suggestions about the new text. It's important that the process was completely transparent, open for anybody to be a part of. And I think that the big difference of the standard, the norm in the ABNT is that it's a consensus. There's no vote. If one person doesn't agree, the text is not approved. It's a great challenge. Such a great challenge, as big as compacting layers in a rainy day. You need to get everybody to agree, people with different interests, from different backgrounds, bringing their own personal experience. But when we talk about tailing stacks, we need to open up this list of options for all kinds of operations. Maybe here in Minas Gerais we are more familiarized with the large tailing stack designs. But we have other kinds of stacks, such as the rare earth, which have nothing to do with the flotation stacks. These are clay, a completely different environments. That's why the more members we get to participate, the best chance we have of attaining consensus. Here's a little timeline to show some of the norm evolution. I included this chart, which is a mineral production chart for metallics, and some reference years where we had some important facts happening, just to illustrate a little bit of how those norms are revised. Usually they are revised between 5 to 10 years. I wanted to understand a bit more. Were there more reasons? Is this right? Is it every 5 years or every 10 years? I wanted to associate that with the production of tailings. I could not get a hold of those data. but the behavior should be the same. The more production, the more tailings. That should be the rationale. I even use the relative percentage, which is the red line you see on the chart. I took the production every year and I divided by the base year, which is the first edition of the norm from 93. The bars are the production in million ton. The red line is the trend, 93. That would be the base year where the norm, the first edition of NBR norm was published. And later in 96, there was a growth, 2006. We saw there was the second edition of the norm, there was an increase of almost 3 times the production. So 3 times the mineral production. Interestingly, this chart then becomes more or less stable, displaying a similar behavior. The beginning, there's a ramp up, but then that's it. I started reading the old norms then since 93, and I recommend you all do that. So you see how the norm matured in its evolution. In 93, the concept of dams was just an embankment on a perennial waterway. Look at the difference 30 years later after, well, more than 30 years. How much progress we made on the concept. And the concept could be different compared to other norms. For example, the hydropower plants sector might have a different concept. And we understand today that dams today can be, when you're closing a pit, you can also store something there. There's this particularity in 93 also. There was no description of factor of safety criteria, return period for water management. But in 2006, the norm incorporated these criteria with factors of safety, return periods, water assessments, a return time of 1,000 years, a freeboard, and perhaps the oldest people here in the audience can remember when we had this change that happened in 2006 and the structures had to be readjusted to comply with the norm. It was a great impact. I remember it quite well. I used to work in a design company and it was amazing. We had a lot of work. But this was not conducted for this reason, for generating more work for us. It was just that tailings production increased a lot and the industry saw the importance of creating a norm with more strict criteria. Then we keep on doing it, and in 2015, November this year, we saw the accident in Fundão. 2017, this third edition of the norm was issued. Some people go and say that the norm was reviewed because of the accident, but that's not true. The conduction of the process had begun early February of 2015. So they're not related, these two events are not related, even though with the accident, more criteria, more restrictions were incorporated into the norm. But this is not related. In this level, 2017 onwards, the standard was basically just being seen in small adjustments to improve the text. And now we reach 2024, where we have a norm that also has the failures, the dam break studies. The text also has that. It mentions risk classification, consequence classification for the structures. I just wanted to show this little timeline so we can understand this context of the norm evolution. And that's what the norm is. It is slow. It is in line with the demand. In this case, the demand was production. A lot more dams were built. I don't have the numbers here now, but it's clear with this chart here. And then we moved on to an effort of standardizing. And that's the path on tailings dam. We're now beginning a process. We have some structures implemented, and the earlier the norm is in force, the better for the sector, because then there will be less rework with the evolution of things. Now I'm going to hand over to Mansour to give you a little summary of what was done on the norm text. The idea was to show you the best that we are aware of until now, but as the first norm, which is aimed towards tailings stacks, we are aware how the previous norms, which were aimed to mining, they were improved. We also have an expectation that this will happen with tailings stacks, and at least in 5 years from now it's going to undergo another revision, and we will likely incorporate a lot of the experiences we will have along those operation years, considering these very recent situations. Here in the norm, the title was changed considering all of the disposal forms, not only dewatered tailings, but also hydraulic disposed tailings, working out the concept of facilities. It incorporates the design of structures for tailings disposal, not only tailings but also industrial waste. And this is an attempt to encompass all of the mining industry. It was divided into 3 parts, considering first the general terms, which involve tailings disposal. Part 2, tailings dams for mining, or dams for mining, which include tailings dam, sediment containment, and water storage. And part 3, which is tailings stack, to dispose of tailings on a stack. 13028 is going to undergo revision, incorporating part 3 and adding some concepts in part 1, which is disposal of dewatered tailings. And for this norm, what's different about it? The design is going to undergo 4 stages since the feasibility study, conceptual, basic, and detailed. It defines all of the studies that are necessary in the characterization for the design of a stack. And that includes the incorporation of a trial embankment. It establishes the key design criteria, as well as geotechnical evaluations and hydraulic evaluations, incorporating waste and waste dumps and dams. It defines today basically 2 factors of safety: for static condition of 1.5 and for seismic condition of 1.1. Or you can use a stress and strain model. The factor of safety for undrained condition will be defined according to the company responsible for the design. The susceptibility for liquefaction will be addressed in the Appendix A of the standard. There are some points regarding this study. The consequence classification follows the GISTM standard for this classification. And there is a specific item aimed towards operation, maintenance, and control of the quality. Within that concept that was mentioned in the first panel, these stacks today, they are becoming much more an operation that's aimed towards earthworks or earth-moving services. These are the main changes, and now we want to debate and answer any questions you might have. Now I'm gonna need my tablet with the questions. The system is asking for a pin, and I always say that computers are great when they work, but sometimes they don't. Mic is also acting like a computer. Sometimes it doesn't work. I think it's tired. My mobile phone. There's nothing on WhatsApp. Let's do it the old way. Is there anybody in the audience that would like to ask a question? We're gonna bring you the mic, okay? And we will ask the question directly, okay? Is there a mic there? Okay, let's try again. Who has the mic? I'm going to handle it very carefully so nothing happens. And let's also pray. Anyways, the first question from Bianca Lacerda is there an estimate for including in the norm the mandatorily control the stacks technologically using an adequate management system? Yes, the norm does predict the need for a QA/QC, technological controls. There is this mandatory action both in operation and maintenance. We understand that this is always under construction. Within this format, which lasts during the whole life cycle of the structure. What are the hydraulic criteria that were established in the revision of the norm? Ask a question from Livia. It is well in line with what 13029 says, which is aimed towards drainage, surface drainage structures. There was also, during the discussions, the matter of the sumps to stacks, and because now it is a comprehensive text, meaning there's a part that talks about stacks and other about dams, whenever there's an overlap, we ended up referencing the part that addresses dams, for example, sizing of sumps for sediment containment. But those hydraulic criteria are very similar. As Mansour said, to the waste dumps and tailings stacks, and even the tailings dams. Both norms are very similar in general lines, with some kinds of criteria in terms of factor of safety. Eduardo Bueno asks, given the particularities about the dams, isn't it better to have a specific stack for tailing stacks? A specific norm for tailing stacks? Well, I'm going to give you my own opinion. I don't think so, because the global nomenclature talks about tailings storage facility, even though they are mostly addressing dams. That was the biggest challenge when creating a text about stacks, because there is an absence of specific texts. In my opinion, it was well done. We have a single norm that addresses any kind of disposal. Today, Brazil is trending towards stacks, but what about tomorrow? Maybe we're going to, trend towards another thing. We can lean towards another direction. And in terms of the acquisition of the norm, you can do it in parts. In 13028, I can acquire within ABNT only part 3, which addresses tailing stacks, or not. I could acquire only part 2, and so forth. I think it was a very assertive matter when it came to maintaining a single text, and everybody knows 13028. It's in our day-to-day. The designs that mention it are going to keep on mentioning it. It was very assertive. Just to confirm that, since the addition of the GISTM, and we sent that to ICMM with a few comments about translation, it's important to say that we adopted the TSF terminology, tailing storage facility, which are tailing storage facilities, as the name says. There was great input from someone that helped us choose. And in IBRAM, in our communication, we don't use dams or stacks, we use tailing storage facilities, because they're more encompassing. But in Portuguese, there's a disadvantage. It doesn't work as well as it does in English. It could be confusing, but we also opted to follow along the same line. A detail is that when we resumed the meetings about the tailings stack, the norms for dams, the norm was published, the 028, and actually this was a guidance provided by ABNT. In the first meeting we had, this meeting in November, the first topic raised was this one, precisely. Whether we would address separately or as one within the tailings disposal section. And we made the decision with guidance from someone from ABNT that was a part of every meeting. The guidance was about this very matter. And this actually accelerates the issuance of this norm.
The only disadvantage of creating another norm, it doesn't look good. You've just published a review of the norm in November 24, and maybe we managed everything we could publish it now this year, 2025, a review of the same norm. Well, wow, you know, did we forget something? Was something missing? I think that's the only discomfort, but the rest of all the benefits that were replaced. We don't have to be afraid of doing reviews when they're necessary. I think we have to do that. Maria asks, what is the guidance about mentioning of internal drainage of waste of tailings dam stacks? Are they the same with waste? I don't remember precisely how it is. I think it's similar. For the internal drainage, it is similar to the stack of waste dump, even by the characteristics. Fabiani asks if the minutes were does this involve the study for the breach? This was a theme that was very extremely complex to get to a consensus. Today, we don't have. Each company has a different way, a different methodology. The Seikodo Minas was the savior of the world methodology people have used, but this theme didn't have consensus of which approach would be given to the stack rate study. It's a more generic study in text initially, obviously in the past, with the experience gained in projects. Maybe a next review will include better guidance of the criteria. Now, on the part about dams, there is an appendix about the dam break studies, which was great progress, and I will point out that it was learning for me during the process of coordinating the norms. I get the norm and went straight to the criteria that I want to look at, the factor of safety, the board, and so on. And I didn't think of doing a detailed analysis. When you receive the report, you just go to the recommendation and conclusion. But the norms themselves are there. Right at the beginning, there's a preface that says, what is the work group that is doing the norm? For example, we have a work group that is working on norms for the dams which are not on mining. Then there's a conflict sometimes in some themes. We have to have clarity. We're going to use the norm if the norm is applied to our norm. Well, I can use the norm of another sector for mine. Well, maybe you could, but you have to be aware that sometimes people use the norm as a shield, self-defense in discussions about criteria. But we have to have this tension, both the what group, where, who is developing it, mining, has its norms, specific norms. The other groups that have other norms. Also, the terms and definitions, like dams, the hydroelectrics sector, a dam is different in the sense of, and as a defining and mining, it's wider maybe than the hydroelectric and other places. Rogério Gomes asks, how be the approach to the co-disposal of tailings and waste? This has already been commented by Paolo today. That's another theme. Which way do I go? Which norm, 13028 or 3029? Then the solution, very happy, got into the themes and definitions saying that they weren't a co-disposal. And at the beginning of the text, mentioning that if the behavior is more for waste, we have to use the waste dumps. If the predominant behavior is for tailings, you have to 13028. It is truly a fortunate way of separating this because the facilities are mixed. We've shown here, cases where there's a little bit of waste and it's filled with tailings. Which way do I go? Which stack do I pick? The norm, the text, to put out to public consultation covers it this way. What governs the stability, the material that governs it is that which will send you which norm to be used. Saliva Masu, it has to be in the technical, the responsibility technical. He has to make choices, and he's competent for this, to make these choices. Mateus Law asks, how do you see the need of a professional working as like the EOR for construction of tailings dumps, waste dumps? Paniako, hearing this, I put it into the resolution. In the case of tailings dumps, the norm now we're talking are tailings disposal facilities. I believe we need an EOR following the same step. The waste dumps, I have a doubt how the process should be. Because of the history, operational history, they have years, 40, 50 years of waste dumps being built in a way, at least as far as I know, there aren't many problems. Real problems, whether stability, though there are very non-serious problems. I'm not sure if we really need to have an EOR for the waste dumps. I don't know. This could be discussed. Because we incorporate all the elements, this generates additional cost for mining. And how much benefit is brought in by that? This question we have to look at. Whether it's worth, in the case of the tailings facilities, at least in the tailings at this moment, the understanding we have of the problem, it's fundamental. Maybe in the future we will have another outlook, knowledge, more facilities built, more sharing of information to assess this guideline. Well, bringing in the concept of tailings and sending to the there it mentions the need of this person, and it can have work. They can have less work on the dams, but this character, this position, this person has to be there. That's the care that we have to have greater safety. Paulo Franca asks if there is any mention of projects that involve structural, non-structural aspects in the norm. He's making up for the difficult questions that were sent to him. In the norm, yes, in the terms and definitions, it makes clear that what is a zone and what's another zone, the structural and non-structural zone, that is clear. That has been stated in this way. There are dumps that have this unique aspect. In the norm, this is stated. Let me explore this a little further, because one of the terms that was very difficult to define is what defines a dump, a tailings dump. What it's very clear to us. No, it is. There's no reservoir. When you begin to look at it, you see it's not so easy. As coordinator, I saw this would be complex because I began to see photographs of dams upstream which were silted up, looking like a dump, and I thought, well, how can someone arrive to a facility like this and say that it could be a dump, but in fact it was a upstream dump. We are at the extremes there. And I made this statement to a group of people. Paulo was one of them, Schneider and others. And this rolled out, well, it began a bunch of discussions and emails went on forever. I was scared. I thought, wow, 4 people of reference don't have a consensus. Think about a wider group. And in the end, it was just suffering in these people, and in the norm, we came to a text that is reasonably, when you begin to create the definition, it becomes almost a page of definitions for you to restrict. Schneider said a lot of the concern in liquefaction, and one thing leads to another, and saying, well, the norm is for waste dumps. I can't have a stack that is subject to liquefaction. One question goes on top of another, and it's chaos, But at the end, I think as we have a succinct summary definition, the norm, of course, we seek consensus. There has to be consensus. Sometimes the texts are more objective and not as wide sweeping as we would like. A lot of people suffer with this because they know there's a state of the art which is much more advanced, but we can't get to a consensus. So people who begin to participate in the process, at the beginning they are at this level of wanting to put the most sort of excellence, but later they begin to understand that the process is slower. It's gradual, as was mentioned here about the stack break. At this moment, we don't have a consensus on this, but maybe in a few years' time we will have. That is, we gain experience. I think it's a process, it's a gradual process, and it's slow. But it has great credibility because there is a consensus. This is the minimum that all in that mixed group agree on. That's it. That's why it is very important making it into a norm, and it gains great credibility. ABNT cannot be queried. Also, the question of the flood path, Paulo Sella showed yesterday in his presentation about the Tomalina dump or stack. We always have to take advantage, and I'm questioned very much about our culpability in terms of disaster that happened. I say it is our role, say NEPA, of the area of investigation. They have to find what happened, and so as it doesn't happen again. There's a system in the course. Their role is to find the other things. It's not our role. So this is very important to understand the process. When we have a study based on Brumadinho, Mariana, we see that the adjustment of the model because of what happened. This was very important because we didn't expect much from what happened. Let's take advantage, Julio, and let's add to the question of stack breaks. Parallel to this, we're discussing a text of the norm, and there's the question of NR22 that begins to require, and people then say, no, but I have to do the study to decide which is the area of influence of a possible stack break. We don't have the consensus of what is the best way to do it. I think we're pressured by these responses, which we don't have yet. And the whole sector has changed. It's migrated to big operations. They've all moved to the tailings stacking. This norm helps as well to give, as it were, to pacify this, because there's a consensus of a minimum text. We have some processes. When you don't have a norm, other players begin to put in their own resolutions, their own laws. I don't know if everybody know, there are two white papers about tailings stacks. Legislators, state and federal, have two white papers about this. Well, if they are things which, even if they are being well guided with technicians giving support, they don't have the same credibility as our process that was done with a consensus. Our state of this norm, I think, helps us in the sector to pacify this, and for the future, greater confidence for mining. Everything works out nicely. This year we managed to have a great change. Within IBRA, we work a lot on this, on the white papers, regulations that appear, and there are situations which are very complicated because we have a white paper from legislators of the state of Minas Gerais to extend the number of dams inside the national dam without any gain in terms of safety or anything, 10-meter high dams, and include them in the policy. What's the consequence of this? A&M will have to receive reports, not A&M, ERNA, that picks up water dams and hydroelectric hydros, and because we have 10 meters, we have 10-meter dams. You think everyone making dam reports and the Waters Agency have to inspect this? You create a work volume which is gigantic without any gain in the process, which has to always look towards the safety of the population. The question we're discussing today in A&M in the Labor Ministry, where you forbid the presence of people who is not working on the facility in the dam itself, in the self-rescue zone, and to follow the norm we try to all the time, but unfortunately it wasn't accepted, is that there are places where you have facilities in the self-rescue zone. There are people working there. There are beneficiation plants, and there are railway loops. The railroads can't be there either, but there are roads, houses in the towns that are within the self-rescue zone. The norm says nothing about them. It's unsafe for the worker of the company, but the person in the community can be there. This brings about an interpretation that is very complicated. But unfortunately, our argument was not accepted. We wanted this to be followed. The criteria of 1466 in Article 1814, where there was this kind of facility or people, though if you remove the dam or if you do buttresses with buttress, and this was accepted by the agency, the licensing and A&M, which is responsible for mining, This could be accepted, but unfortunately we haven't been successful in this discussion. Eduardo Bayo asks another question. With the publication of MBR 17188 about dam break studies in Dadi, Annex A of 1328 will be maintained. This will be put to consultation nationally. On the national consultancy, it will be discussed only with regard to the part of chapters that were changed. But it could be that some comment will come to exclude this. This could be assessed within the Commission or the committee. As I see it, no, I think we should keep it because norm of dam break, it was discussed in a group which was not discussing mining dams, in spite of the severity which is similar, but it could be there are aspects, specific aspects in mining that don't. Let me give you an example here. The ponds. How do you do this? There is no spillway for the pond. Well, how are you going to simulate it? The water level on the crest, on the edge, because the norm of dam break study establishes some scenarios of the maximum level, maximum water. There are unique aspects of mining that are of mining. This norm was developed by a group that are not from mining. Although there is participation open to any person to participate, people in mining, I think there could be some text that was not, didn't include this specific aspect of facilities in mining. I come back to the beginning about the preface, what was the work group, what's the scope, what's the applicability, what are the definitions, before using them directly. Although Resolution 95 now, the new proposal, A&M, is that we should use this norm. I went there and made a suggestion of excluding this because 1328 includes this. It has an appendix about these studies. I think it shouldn't be there, but it's my own opinion then. Maria asks as well if the norm will bring in criteria for specific closure of the geotechnical facilities and hydraulic facilities. The closure side of things, it is similar to 13029 with the concept of closing the facility progressively as it is implemented. But there's the obligation of the design to, together with the design, you should also do the plan, conceptual plan for closure. Well, I think as time is running out, I'd like to leave last. The norms of BNT can be accessed freely by professionals who have the registration, who are up to date with their fees. That practically everybody is into that. So I would like to ask you to give your final remarks, please. I would just leave the invitation when people enroll in the site of ABNT in CE 220, and when you receive the proposal, the minutes of the rough draft version which was approved in the Commission, so that you can input your suggestions. It's important. Maximum comments, information, so that this will go back into the meeting of the committee, assess each comment, each suggestion, to see it's relevant, and then we will manage to conclude the process and have a norm about the tailings and stacks. I would like to say thank you very much to IBRA for the opportunity to be able to make known more widely this theme, and especially Julio and Aline. I'd like to thank as well those who were with us. First, it was the technical group meeting on Mondays at night. Then the team that participated with frequently in the meetings. I would like to thank everybody who helped to build the text, which is with ABNT, and soon it will come for public consultation. And congratulate Fernando Saliba for the brilliant guidance at the front of the norm. The Commission, because really seek the consensus is not an easy task. Very complicated. I can't see Aline if she followed Emma. She has to go back to Australia today. She arrived 2 days ago, and Aline, there you are. Oh, here she is. She hid behind the wings. She's the great person responsible for the organization of the event, and I would like to thank her very much for this. You can see this event. We had something which is learning in IBRA. I participate at least once a month. I'm in some panel in some place. Next week I'm in Rio Grande do Sul, and the state legislature. With all this participation, it's the first time that I'm able to know the questions that come from the audience in 90% of the questions that came. Unfortunately, a few questions were not answered. I can say to you that 90% were answered. And we saw in the previous panels that most also was answered. Well, not sometimes all of them. It's very important because today we had a great participation of the audience, which is fundamental for us to do this exchange of experience. But I would like to thank all of you for all the panelists. Paolo, who we can joke with him because we've been working together for more than 30 years. It's been a long time, isn't it? Yes. But not only are we friends, but our families are friends as well. Our wives are very great friends. Somebody with whom we feel very free. The fact that he is regular in our seminars, in our work, that whenever we need help in geotech, Paulo is always willing to help us. We thank him very much for this. Aline, please, as the person responsible, say the thanks, final thanks. Just to make an official photograph of the last panel. You're going to call up, yes. Okay. Let's do the official photograph with Saliba and Marcio, please. Thank you very much. Please go back. A geologist with a suit is the most awkward thing in the world. We are following to the closure of this edition of Tailings Brazil 2025. Before passing the floor to Aline, I would like to say goodbye to you. Say it was a pleasure to be with you these 2 days that were so enriching. I think we'll go home full of a lot of information and reflections. And so I invite Aline. Aline Nunes is Mineral Issues of IBRA to close this edition officially. Thank you, everybody. Thank you, everybody. who remained to the end and were with us in this path. I will follow with the help of the communications team. Good afternoon, everybody. This is the third edition of Tailings Brazil 2025. This edition confirms the importance of being in constant contact and to discuss something which is so important for our mining sector. In IBRA, we continue to work to support you, constantly investing maximum attention to keep tailings management in harmony with the highest standards of the world. And for this, we need to constantly seek the technical update, as we've done once again in the Tailings Brazil 2025. Well, special thanks to the sponsors, BVP, Category Diamond, San Marco, Silver, Alzenco, Nexa, Bronze, Andric, and CBMM panel, and our panelists who gave their time and were generous to share knowledge in the debates that happened on this stage. I would like to thank also especially GPESG, Mining of Brazil of Dams. GP of Dams was essential for help us to hold this event. I'd like special thanks to them and to all of you who are in this audience, came through, interact with the questions that were stated here, and who would like to ask you all who participate in the survey through QR code on the back of your badge. Now listen please for a quick video of the President Director, Hao Jungmann.
Projeção ganha maior importância e, evidentemente, esperar contar com ele nos próximos eventos. Gostaria também de afirmar que, para nós que fazemos o IBRAM, a questão da segurança, repito, ela é, sem sombra de dúvida, essencial. Cada vez mais nós queremos ser um setor responsável, um setor legal, um setor sustentável. E, para isso, evidentemente, programas como esse, seminários como esse, têm uma imensa relevância e são importantíssimos para todo o setor. Por isso é que eu faço aqui os meus agradecimentos, na certeza de que nós cumprimos nossos objetivos. E o Tailing Brasil 2025 foi revestido de amplo sucesso, mas isso graças a você, participante, a você que participou como especialista e todos aqueles que contribuíram, inclusive a equipe do IBRAM, para que esse encontro fosse verdadeiramente um sucesso. Muito obrigado, felicidades a todas e a todos.
And joy for everybody. Well, thank you very much. I thank you once again. And God willing, next year we will have the 4th edition of Tailings 2026. Thank you, everybody.
Very good.